upgraded us last summer, which was nice. And they fixed the screen to where it actually works too. It's no longer, it was really, really broken for a while.
Yeah.
Probably, I don't know, this was where we left it 2 weeks ago the last time we were in here. I have zero idea what my kids do. I think that's a face of some kind.
I think the answer was B.
No, I think it's sunglasses.
So for the trip up to IRI,
Yeah.
leaving Wednesday, we have karaoke on the bus.
Are you serious?
Yeah.
Are you, like, the bus has it?
No.
Oh, you found a way to do it.
My laptop, my portable hard drive, guitar amp, microphone mixer, two karaoke, decent quality microphones, and on the bus.
Good to know the sound quality's okay.
going down to NASA to practice with 118 and 624 for the Indiana Robotics Invitational. And then 2 weeks later, we'll be at Robot Roundup in Austin.
It's only 2 weeks.
2 weeks from this next week, guys.
Probably plan
Yeah.
that. But yes, well, a lot of teams start meeting year round. So right now, I've had my break from robots for the last like 2 weeks while all of my students were running a Lego robotics camp at a Boys and Girls Club. So I haven't shown up and they've just been doing that. But before that, we were meeting most of the time, about 6 days, 5 days a week before that, doing stuff, prepping for, we just hosted an off-season event in June, some of you guys were at. So we were doing a lot of prep for that, and then other things with the robot. We went up to Fort Worth for competitions, and we're doing things year-round all the time for the most part. This is probably the longest I've been away from like seeing my kids in I don't know how long, for like 2 weeks.
Yeah, I took some time off in May because just needed a break. So a few weeks actually I was catching up. I do teach not teach. I retired from the classroom in June. So this past fall, the school district hired me for 17 hours a week or so. I'm a robotics instructional coach, so I just go around the district and get robotics teams started. So we started a dozen FLL teams last year. We have another dozen coming online this year. We had 9 VEX robotics teams that got started last year. We're trying to start a couple of more first teams in the district, but that's a longer process. So I'm going to be quiet because the camera's on.
The camera was on you the whole time, but it wasn't. You just weren't very much in frame. Right.
So I'll give you my background so you kind of understand why I'm not an expert on anything. I graduated from A&M in 1983 with a Bachelor's of Science in Aerospace Engineering and promptly jumped into the classroom, and everybody thought I was crazy. And I taught for 30 years. Pretty much everything I know about electronics and pneumatics and all of that stuff, it's pretty much based on high school physics level, like AP or pre-AP physics level stuff. And that's all everything I know about electronics, I just kind of picked it up by hacking through stuff and reading things. And a lot of times I don't know what I'm talking about, and then somebody like Alan or James Tomtat, who's a friend of mine, he's another mentor with our team, and they'll say, no, it's not that way. Oh, okay, and that's how I learned. So it's a little more expensive sometimes, but I don't do this. I'm pretty good at that.
But how long have you been in FRC?
I told them I was involved in 97, 98, 99 a little bit with the team, 275.
Yeah, if you've already told them, I know, but
okay.
I forgot I had left the room.
All right.
So a little bit about my background. So I started FRC as a freshman in high school in 2003. I was with Team 647 out of Killeen, Texas. They're still around today. Did that for 4 years, did a bunch of stuff with them, and then came to Houston to go to Rice and took a small-ish break from robots for a year, although I still went to like 2 competitions, so not really a break. Just didn't actually build a robot that year. Realized I needed to start building robots again, and with Andrew Lynch, who currently runs the Discobots, we started the Discobots at Lamar High School my sophomore year of college. And I stayed with them for 4 years, and then got the opportunity I had a friend who was working over here as a math teacher. Their person who was running their engineering club thing at the time was retiring from that. It's actually still his classroom. He still teaches physics in here every day. But he doesn't do the robot side of it anymore, and they were looking to bring somebody on basically as like a part-time, like what they would pay a part-time lacrosse coach to do. And I was like, ooh, pick me. I love this stuff. So then I came over here and got the opportunity to basically be an engineering instructor, but not have classes. So I'm here every day at 3. So I just run the team. I don't grade anybody. I don't do anything like that because I don't want to do any of that stuff. They offer a lot and I turn it down constantly. Part-time, I do engineering stuff in the morning, so I do actual CAD stuff. Almost everything I do on my job, I learned from FRC teams, not from my education, like my formal education. Like I never had any formal SolidWorks or CAD training in college, but we had pre-engineering stuff in high school that I learned, but most of it is all stuff I did in FRC. So if your kids do really well in FRC, they can do all sorts of things, because I do 95% of the CAD for my company, basically. We're really small, but it works out. So yeah, most of everything that's gotten I know is all from strict FRC experience, not from real world engineering experience much at all. But that helps when we're talking about FRC robots, so that's good.
Have them.
Yeah, I was say we can do quick intros around the room, so we can get much faster than ours.
Yeah, don't tell us as much as I told you.
No, no. Oh, by the way, this stuff is being slightly recorded, but I plan to, like, if at any point you want to say something that you don't want recorded, let me know and I will happily mute. So we will be, you know, if we need to talk about students or anything, it's fine.
Can they say that after the fact? Like if they say something?
No.
Oh.
Don't say it after the fact. Say it before. Because no one, it's streaming to YouTube. No one's watching the stream, but I do that so that YouTube automatically records it. So don't say it after the fact. But we can do intros.
Into the spinning wheels to fire the frisbees up. And so we would mount a GoPro on there all the time, and we'd get back to the pit and we would look at it and we'd say, oh, look what happened there, look what happened there. And so we were able to make changes to the robot that would have been guesswork otherwise. So the GoPro was really helpful for that, and then it's cool.
Some teams use really, they use some really high-speed cameras that you can get, but the GoPro, you can do low resolution at like 120 frames per second, and that gets pretty close.
Use an iPhone.
Yeah. Depending on
just slow it down.
We have a couple of the kids will whip out their phones if it's something quick. Because media is not always there.
Yeah, but the GoPros are nice. Day after Thanksgiving, the time to buy them.
So why don't we'll start over here on my left side. I guess your name, where you're from, team number, and experience with FRC. Is that
covers it?
all right?
Sure. Javier Chavarria. I'm from Ironclad 3103 in Houston. Just starting with the FRC about a year ago. My daughter is a freshman, incoming freshman at Duchenne, and so now I'm mentoring.
faster for me is because I had some really good people and kids around me that explained a lot of things as we went along. There's a lot of stuff that happens on the team, and I don't understand it. Okay? It's okay. Especially on the programming side. I understand basic programming, I can do some code, but they do it, and they do, to me it's like black magic. That's why I can always blame them. But this past year I couldn't, because it was always an electrical issue, always.
Yes, not software.
Not software, not
I'm
a
a
single
software guy.
guy, not a single guy. That was a good feeling, because when something wasn't working, we'd just go, hey, we could go back to it, and we'd always revert to old code. If something was going on, we could revert to what we knew worked, and then if we still had the same issue, then we knew for sure it was a hardware issue or sensor
So
issue.
you blame the programmer first.
Well, it's so quick to revert to the old code, so it's just a troubleshooting method.
No, even if we know it's not code, we blame the programmers anyway.
It's always a software issue.
Yeah, 704 programmer got blamed because the key came out of a wheel and it wasn't turning, so.
Well, that's one of the things we like to say is we can fix it in code. Fix it in
I
code.
work at Lockheed Martin, we say that too.
Okay.
You guys are so mean.
Lockheed Martin in Grand Prairie.
Yeah,
I worked there when it was Lock Corporation.
when it was Vaughn or LTV.
Well, it was LTV.
Hey, I remember you now.
I spent time at Marshall Street and at the main facility.
I was playing like
Dave Schumann was the guy I worked with.
you recognize the name.
He did Space Shuttle Tots. The leading edges.
Yeah.
Cool. All right. Back to FRC stuff.
Sorry.
How do we want to get started in? We didn't really decide this.
Do we have an agenda of what we're hoping to kind of discuss today, or nothing? Okay.
We have things that we have things ready to be discussed. We just don't have an order or know if you guys want to hear about
I
them.
guess it's because there are so
Then start.
many, so we don't know
Let's
based
start.
based on questions. So how to start a new team?
Here we go.
Yeah,
Team
we need
stuff. That's-
Just do time.
So a lot of that we've talked to several people about offsite and stuff too. That's definitely a tricky question, how to start a new team. But we can talk about. I guess we can run
How
down all
about
the
this?
different.
We limited the 5 things you need to do when you start a new team instead of like count everything. It's too much.
So much of that, one of the things that we'll talk about, and you'll hear me say a bunch of times, you have to figure out what the resources your group of people, team, whatever you want to call it, has, and how you can best utilize them. So for some people, it is going to be funding. Funding is going to be the bottleneck for a lot of people. Some people it's going to be space. Some people it's going to be something. There's going to be a limiting resource. Figure out what the limiting one is and try to make it not limiting, and then figure out what you have excess of, and figure out how you can use it to do everything else that you have with it. So my team, Spectrum, we literally have one mentor I'm the only person that's really ever here. Like we have 2 other faculty advisors who help go on trips and stuff, but for every build meeting, it is only me. We have some really dedicated students though, who are willing to put in a lot of time. We have very nice schools who are willing to give us the space and let us stay here really late and do a bunch of other stuff, and they provide a bunch of other things for us that we can make up for the fact that it's basically me and 30 kids, which we've made work. But other teams have, they can only meet for 3 hours, so maybe time's their limiting factor. They don't have money, something like that. But whatever it is when you're starting the team, figure out where your resources are, build within those resources, and then expand the resources as much as you can, and figure out how to make it work, basically. Like there's no model that can't be an FRC team. Somebody's doing it somewhere. Like there's teams who are literally like, a family, and that's basically it, with a couple neighbor friends, and they will build an FRC robot. There's been middle school teams. There have been everything and imagine in limiting resources, and then you have the teams like 118 who are, they build in a NASA shop. So they're the normal counterexample to the small team, but they have 60 students or whatever. And a lot of times they're at the same competitive level. You can still play with them.
So how many people you're either starting from scratch or your team has like less than 10 people on it right now?
We have
25.
Yeah.
But you're starting from scratch.
You're starting from scratch, or your team is less than 10 people. So
We don't have a robot. We don't know.
Well, but I mean, do you have any students? That,
We have some students.
so, I mean, that's the first, for me, it's the first thing is, the first thing you have to figure out in the fall is who's gonna be on the team.
And that can definitely be your limiting resources. There are teams who students is their hard limiting resource. We'll have 6 or 7 mentors and 3 or 4 students, and that exists. So they have to do a lot of recruiting and figure out ways to get students.
So, what we do, right now, we're at a point where we finally got to the point where I think we're self-sustaining, so that our seniors graduate, they've taught enough stuff to the underclassmen that the juniors step up, and we use the off-season to get everybody else up to speed, get not the new kids. The new kids, brand new kids will come on board August and September is when they'll join up. And now it's pretty much just word of mouth for us, because we don't go out and do any recruiting, because we already have, at the high point of our year, we had 80-something students registered. We have an online registration system that we use. According to FRC, we have 65 students on the team. When we went to champs, we took 20-something kids to champs, 29. And those probably have about 30 kids that are there consistently. During the summertime, not as consistent. But, you know, back in the old days when I first started teaching, during the summertime, I never saw a student. So that's changed a lot from what it used to be. But we used to recruit. We used to go out, we do a demo at Oak Ridge High School, we do a demo at the Woodlands High School. Our team has students feeding in from Oak Ridge, the Woodlands, College Park High School. We have homeschool students on the team. They're word of mouth. They just hear about us and join us. We have a kid from Montgomery High School that joined us because his cousin was on the team and he found out about us through our website. We have a kid that comes in from Jersey Village, same thing. You know, just heard about it. In fact, he was working with Disco Box and just decided they'd rather work with our team. So they started showing up. And we have a really open policy.
You know, he's the only one. He's been mentored by both of us because he started in disco when I was there.
Oh, did?
Lance has been going through the whole time.
Oh, yeah.
Are those schools that you wanted to mention all within the same district?
So 3 of the schools, College Park, the Woodlands High School, and Oak Ridge High School are all in the same school district. The ones that aren't in the school district, when we go travel, they're completely on their own for travel. All those, there's like 5 or 6 kids that are not part of Conroe ISD, that's where I teach, or where I used to teach. Part of Conroe ISD, and so they have to arrange their own transportation. They did let them ride up on the bus this year with us, and they let them stay in the hotel rooms, which floored me. A few kids, we had like 2 or 3.
Well, I guess what I'm wondering is your district, because like our district has one high school, so we have no other school front. We talked about possibly having a neighboring high school, Southwest ISD, work with us. And it's like, when I went to the principal, it's like, well, we have to get lawyers involved. We have to have legal documents.
No one,
That they'd stop.
in general, nobody knows. I mean, there's not like, until this past year, nobody high up in administration was really aware that that was happening.
That seems like it's the best way to do it.
Well, sometimes it is.
Yeah.
I've been beat down enough
Right.
times.
It very
doing
much
that kind of
depends
stuff.
on what resource you have, what administrator you
Their first
have.
comment was, if somebody gets hurt in our shop.
And I think that's maybe your issue is you're organized so that it's a school activity, you use school resources. It depends on the school. Because we've got things that we can't do because we are using the school district and school resources.
I guess mostly I'm wondering, does anybody have the documents where I can go to the principal and say, look, this is what another school is doing? Can we possibly?
Don't mention my number.
Off the top of my head, I don't know of any inter-district public schools that do that.
I can ask around and see if anybody.
I mean,
Well, the primary reason we want to do is Southwest is possibly going to start their own team. It's like, okay, then join with us for at least a year, see what it's about, start learning it that way, and then.
So what Bastrop is doing, Bastrop, Manor, and Smithville are all 3 kind of tiny towns near Austin, but not close enough to get like Austin support. And so
Agatha, can you come to the front office? Agatha, to the front office.
So like the Manor team basically mentored us, and then the Bastrop team is now starting a team in Smithville, since our principles are the same way, you can't have all the kids work together because of liability stuff. We apply for grants that say like, hey, we affect all of these kids in Maynard, Bastrop, and Smithville, and then we split the grant in 3 ways. So like that helps us with funding, and that's how we're able to support kind of like continuings. It's kind of a weird thing, but that has worked for us.
My high school team was a multi-district team. I'll see if I can contact somebody, but we did all of our work in a data facility, so probably it was off-site, and that was
I think
probably
it's just a matter of honestly getting a lawyer in to say, just do the documents, and you're not responsible, blah, 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 but it kind of froze.
So get a parent as a lawyer to draw up, or?
Well,
This is the only parent that shows up.
Who's chief though?
Connected to the law school.
Our district wanted to. Don't worry, I did a request on Delphi, and we sent the information that said, oh, this is gonna cost us too much, so we're saying what we have. The other thing is, don't definitely be done with the lawyer stuff, because she may have an accident, but we're all fingers and alumni. We are checked every year by the lawyers and the risk management and some industrial safety people, we have a shop. We can't do anything that will piss any of those people off, because we don't wanna lose our shop. We should do it right, if you have a shop.
I have a quick question about Tim's. Is the W9 thing or whatever, is that a new thing this year?
It's always,
They've been doing
it's always been there
for a
as
while.
long as I've been, whatever, alternate contact on Tim. I'm not the main contact.
So, like, we are in the process of getting a 501c3 tax ID number or whatever. Would you probably recommend just holding up and doing it until we get the tax deductible ID, or is it supposed? I've been a little confused as like what information it is that we're supposed to be putting in there, but I think once I get out the tax ID number.
Yeah, I mean, when I got involved, we already had
Okay.
the W9 set up and everything. We do have our own association now, separate from
Yeah, because I would think it would be difficult for some teams that don't have that tax ID number necessarily or whatever.
We did it as Bastrop, we used the schools until we got our own nonprofit, and then I just flipped the forms.
Okay, yeah.
We're entirely within the schools, so, well, we're 2 schools, we just do everything mainly out of St. Agnes, so we use theirs, like all the budget stuff comes out of St. Agnes.
For new teams, there are a lot of resources on first.org.
Yeah.
You have
US
to hack
first.
around a bit, but it's also well worth your time to hack around a bit.
And there'll be lots of times where we talk about resources. One of the things that got mentioned briefly, but for people who don't know, chiefdelphi.com is the water cooler of First. This is where everything happens, basically. It has archives back to, I think the oldest posts are 95 or 96 that are still on there, maybe earlier. So you can literally go through and know everything that's happened in First history by what people have said on this message board.
Oh, hey, that's me.
It's actively around. Oh, you're logged in. Okay.
Yeah, I'm always logged in.
Yeah, I know. But yeah, so there's people talking about IRI predictions, IRIs next weekend. So yeah, there's stuff literally all the time. Everything you've ever want to know. Search. Somebody's probably had your problem before. 95% of the time that's true. Probably 99% of the time that's true.
Also take
100% in my case.
take the rumor wheel with a grain of salt, because sometimes it grinds
Oh, yeah.
people's cold.
Knowing what not to read is more important probably than knowing what to read.
Yeah, but technically, I mean, asking questions on that is a great place.
Yes, ask questions, but search first, please, because otherwise you'll just get a link to somebody else who did the search work. So
It was like this,
Yeah,
that
like
2015 game one.
something like that. Don't read it. It's not
Yeah,
worth
it means nothing. There's 196 replies.
It's a bunch of random people who don't have any.
Yeah, I'm sure.
Oh yeah.
It's a flying game or a water game or flying water.
Here's a good example of like this. I don't know what the outcome of this one was, but it says packet loss spikes at 1 minute intervals. Now, half of us in the room probably don't know what that means. But you know, if at some point somebody tells you, oh, well, you're losing packets at exactly 1 minute intervals, and then you come on here and you post. Well, first you search, and then you post something, and people will reply back. and try to help you out.
I don't think that it wasn't resolved the last time I read that one.
Was it?
So like, there's people like me who sit there on Chief and read random threads and then solve problems. So there are very few Chief threads that I don't read.
This is why we don't have an agenda.
Yeah.
He was
Sometimes I
reading
just,
Chief.
actually go to Alan's profile and just read his latest replies.
I really hope you don't do that.
No, I do.
That's really weird.
You officially have
I
stalkers.
promise it is
Here's-
not, I'm not that
here's my
eloquent.
thread.
He then knows
I am not that eloquent.
what threads to read.
Yeah,
If you wasted your time reading it, it must be good.
yeah, but I mean, there'll even be, so one of the things we were just doing, a team, 4587 Jersey Voltage, from Jersey Village High School, one of their kids was doing a summer CAD package, and they decided to CAD up a robot over the summer, and then posted the picture of it, and scroll down a bit, there was a bunch of people posting robots now. It's down here.
Yeah, I know.
There it is. So that's his latest rev of the chassis, the student on the team CAD'd the whole thing. But he posted it, then says, you know, ask basically, where do I have problems, what is going on, all that stuff. Then scroll down.
See, there's me. I looked.
Then scroll down, all the people are talking about the chassis. There's me.
Yeah.
There's a little GIF that one of my kids made of a.
That's Alan's dad, by the way.
Oh, yeah.
They are each Woody finalist. Woody finalists.
Woody Flowers finalist.
Woody Flowers finalist awardees.
What's the
Woody Flowers Award is an award that's given out to a mentor at every regional based on a student essay. Scott is also a recipient. So this guy, Austin, is a mentor on 971. He's one of the best teams in the world out of California, and they build ridiculous drivetrains too, and they have all sorts of people. So even if there's a team who may not have, you know, huge amount of engineering support or has never done a certain design before, you can have a kid or yourself post something and say, hey, I was doing this, does this look right? And people will go through and literally just say, you know, break down exactly what's wrong, what's right, and everything. People will post full CAD models or post full ideas, and you have basically the entire FRC community working on a problem. So with like this one specifically, at one point I was like, oh, this is kind of cool, Cooper, can you send me the CAD? I need to do something on it real fast. And like he sent me the CAD files, I played around with it, sent him pictures back, and we were working through different iterations on this thing basically. It was originally the drivetrain he was building was slightly inspired from the one that we built earlier this year, so we were advancing it for next season.
Well, and also the shape's kind of 148. Is that
Right, 148.971 bolt did it.
Yeah. Okay.
And then we were, so the iteration is basically that. It goes into somewhere along here. We learned to like tuck the motors and do some other stuff. So we were working on like how you can get different motors and gears and all sorts of things going on. But yeah, so there's tons and tons of stuff on there, and that is the single biggest resource. So most of the stuff that I know about robots is from spending a not healthy amount of time reading things on Chief Delphi.
So here's the kind of thing that doesn't make any. Well, I don't know. Well,
Some
let me
of
see.
those are slightly
Let me see what this says.
Right. So that's John Nichols. He's a friend of mine actually. Met his hands before. They do things like that. So they're, you know, you'll get the people on other teams who would end up basically being like the ESPN analysts who would be like
Right.
predicting who's going to win the playoff series in the NBA. You have people at Chief who do the same thing for different events.
This is our Champs Alliance, except I don't know 910.
Yes, he did have that prediction coming back. I think he really liked that alliance.
Another useful thing of this is a couple years ago, when the Lone Star Regional thread came up and we said we were attending, one of the problems we have, because we started traveling when there was no competitions on the West Coast, and we still do, trying to find things in Texas or in Houston, and Alan came up and said, would you like some help? And we were very, I said, oh, thank you, we got a connection. Because getting our robot to places now is more difficult than when you used to ship them. So you need contacts on who to contact. And this is how we got it, is Alan came to our rescue.
The FRC community will do crazy things. If you're, you know, desperate, you need a part or something, people will mail it to you. I mean, I've mailed there's a rookie team in Tennessee who blew one of their electrical components, their sidecar, for people who know what it is. And they're like, oh, we need to do demos and we don't have one. And I literally was just like, oh, I have, like, put it in a box and sent it in UPS to somewhere in Tennessee. Because
Lost the championship because they gave the part. They gave the Master Link, the one won the match about 2006, I think, or 7.
I think it was 6. Yeah.
Yeah, they team broke the drivetrain. They were the better. First match they won, they were the better line. Second match, the robot broke and they lost. there's too long back in the lines that you could not get to the pits in time. And the alliance that was the second best alliance had the spare part. Do you give it and lose, or do you keep it and win? They gave it.
You give it and win.
That's the
But
goal.
you know, but you know when the announcements are going to go to the other team, and Dean will celebrate the other team. They only won because the other alliance was willing to make the sacrifice.
Yeah, and
that's first.
gracious professionalism and cooperation are two words you'll hear, or two trademark things that you'll hear a bunch. And are foundations of the whole principle. But it's one of the reasons why it's amazing. You get to compete at a ridiculously intense level. Everybody who's ever been a drive coach has said something in the driver's box or to someone they didn't actually mean to because they were competing way too hard. But at the same time, you can be competing like crazy, but if one of them were to walk over and say, I need to fix this, you hand them whatever it is they need to fix it, you get the robots on the field, and you compete at the best level you possibly can. Like, there's no,
I'm always in control when I'm drive coaching.
Absolutely.
Yeah.
Never once.
It's an act.
Last example, statement of that, Team 100 at Silicon Valley one year in the finals, there's no way they would have been only winning alliance. They had parts on 5 of the 6 robots. Everybody needed parts, they supplied them.
There's a gracious professionalism award, but even if that team did get it, that just enhances your reputation.
Yeah, and it's
people
not-
know.
It's not for the hardware isn't the reason we do any of this. Like the trophies and places.
The hardware's nice,
They're pretty. They're little towers.
but they clutter.
Yeah. We don't have, especially when you get really big ones like God has.
Lots of
But-
nice
They don't do those much as they used to.
Random people who don't know, Texas Torque has won the world championship last year and was world semifinalist this year.
One Archimedes, so
Right. So they were a division winner. So they have big trophies.
like they used to give in 2008, the trophy for Lone Star is
Right.
the same size as the champs trophy now.
Yeah, we got those shows.
Okay. So who have we already lost completely?
Sorry.
So again, please stop us with questions. We will get off into First Land pretty quickly.
I
One
can-
other thing about Chief Delphi, the thing I find most useful is the white papers
Yes.
section.
Oh, it's a good place to go
Probably
down.
More than anything else, and it's where I direct people, because if somebody's looking for fundraising or design, it just doesn't matter, somebody's done a pamphlet.
Yeah, so basically anybody can post documents to the white paper section. If at some point you do something that you think is kind of cool and you want to post it, feel free. I would say that's a PDF version of our build season blog that we put up every year. A lot of times, one of the reasons I post things in the white paper, most of the time, same thing will be posted to like our blog or our website, but I'll post it here because I know that the odds of Chief Delphi being down or that Chief Delphi will be around far longer than Spectrum will probably be around. I have no idea if Spectrum's ever going to not be around, but I know that I can still get the white paper from 1995 or like 2006. I helped write Nothing But DeWalt's, and I can still go download it from there. But the Cyberwolf Core webpage that from 647 that it used to be hosted on too no longer exists. So all the cool stuff I try to make sure it gets on here, so it's
And better
preserved
visibility, too.
forever.
A lot more people will see it.
Sometimes.
Well, they search and then.
Right, it just depends on what it is, but like, our blog actually gets decent follows.
Yes, ma'am.
What's the difference between FTC and FRC?
So FRC is the big robots. They weigh 120 pounds, without bumpers, without the battery. And the entry fee is five this year?
Rookie teams are 65.
Oh, that's right.
5,000 for
Rookie
veterans.
teams. So veteran teams, $5,000 for your first regional, $6,500
6,500 for rookie team.
for rookie.
And so FRC is the varsity level program. So
FTC is also high school,
right.
but the robots are much smaller. They're
FTC,
like this fitting.
It's also the box.
VEX, BEST, all of those type of programs are great. They're really good engineering competitions. They're fantastic. They are not the same experience that you get on FRC team. Plain and simple. Like, it's just not there. It might be for some, if that's where your resources are, it's great. It's better to have any engineering program than nothing. But if you can have an FRC team, FRC
At one
where
time,
you-
we sort of used, like, my school was involved in Best Robotics, and they still are, I just don't support it. So, the idea was kinda like, it'd be a proving ground for kids before they would come to the first team. But now, my mindset's different, I'd much rather have a freshman come in, and I invest some time in training them, and now I get to benefit from that for 3 years
Right.
after that investment.
It really, and it depends on what your team is built up as, how you're doing it. So if you're a program across a ton of schools with a ton of different teachers who can all be running things differently, you can have FTC, VEX, or other programs at a bunch of different schools. If you're a single team, it's sometimes harder because it's hard to have 40 kids work on one of those type of robots that's too small. And you just figure out where you need to be. But they do work really well for teaching your kids how to do, like how to run a competition team. It's way better to have them learn how to make sure they get to their matches on time when it's a VEX match and it costs you, a couple $100 to go to the tournament for the day instead of the $5,000 it costs you to go to an FRC match. So you don't want kids missing matches at FRC level at all. So
They only do it once.
we almost missed a match at Champs. That was bad. Really close this year. We did it though. But yeah, so getting tournament experience, all that kind of stuff. Please have your kids go to tournaments, even if they're not competing in them. Show up, figure out what it's like. Because you can't really train somebody what the whole show is going to look like until they've gone. So off seasons, other regionals, anything like that, have them volunteer, help. They'll learn a lot, especially the behind the scenes stuff. Actually, we stopped competing in the fall. Now we only volunteer. So our students do reffing and queuing and all that stuff. So they learn how all the behind the scenes stuff works. So when we're at FRC events, they're like, oh, I can do this or help that. They know how it all works on that end. Okay.
So what else do you have planned?
Today,
Yeah.
I'm gonna,
That's what I was about to say.
he's
Mostly-
about to make me do
I
pneumatics.
think we're going to start with pneumatics. It's a reasonable place to start since we don't. Greg McCaskill's coming in with the new control system, which is what we're kind of waiting for. We're just not sure when he's getting here. But we can do pneumatics without it because that's not going to change the new control system.
Right. And it wouldn't do any, I would normally I would kind of think of doing electronics first, but it wouldn't make any sense to do that because the electronics changes so much with the new control system. And changes, I think everything that I've seen is in a good way, so.
Yes.
Much smaller footprint.
He's a new guy.
Absolutely.
Hopefully not waste a bunch of people's time, but as far as the rules go, how restrictive are we on parts and stuff? Because it looks like there's a lot of commonality out there, and there's a lot of stuff that's pretty.
Yeah, there is a hefty manual. It is very important to read it.
So I was lucky when I started with 1477 that they had a lead mentor and he knew all the rules forwards and backwards. So I would say, could we do this or could we do that? And he would say no, that's not allowed. And eventually I got to the point where I know all that stuff now. Or I don't know it all. I know a lot of it.
Have
You know where to find it.
get somebody on
You
your
know where to
team
find
who
it.
is the rules expert. That
Don't
is
be afraid to ask the other
right.
people around.
And ask people, in the city, whatever. Like I'm pretty good at the rules. I've been
So as parents, how much you
I would say that it would mostly just be like come to me or Laura or one of us and ask us, and then if we don't know, we can go find out or whatever.
So this is a group.
Yeah, she's one of our parent mentors.
Just making sure.
But to answer your question kind of about part availability, so for the most part, on the mechanical side, it's pretty unlimited other than like cost restrictions. So like the robot can't cost over a certain amount, which
And
is
motors.
right, and motors.
Motors are not-
very, very restrictive. You have a very small set of
I would say
motors. Well, it's opened up a little bit. There's about 23 motors you can use now or something like that. But there are certain ones that you'll be using. I have no idea what that was.
I don't.
You have an HP update.
Oh, that's what it is. Okay. That makes sense.
Great.
Okay, good to know.
Cancel.
So
The other thing you have to be careful of is pneumatics. The rules are not very restrictive, but you really have to pay attention to them because they will fail you
right. So
if you do something stupid with pneumatics.
there's a couple different things that you'll get. Basically, the full manual is that you absolutely need to read through it. But by midway through the season, they'll release the inspection checklist, which gives you most of what you need to make sure the robot abides by. Especially for new teams, at some point before you're finished with your robot, there'll be an event where I will be there and most likely do a quick inspection of it. Hopefully it'll either one of the scrimmages or one of the rookie builds or something. We do quite a few things in the middle of build season. I'll try to get around to most of the pre-rookie robots as soon as I can, and walk through and find the stuff that's wrong on them, basically, because there's always stuff wrong. I mean, the goal of other LRIs are to find things wrong on other LRIs robots, and it happens every year. Like, you're always finding something that doesn't pass inspection.
LRI, Lead Robot Inspector.
Yes.
They'll be wearing a hat like this.
Oh, hey, it has an inspection hat.
I have my inspection hat.
Yeah,
Like-
mine's really dirty. Mine does not look like
Forgot I did that.
If I can also contribute, right, I would think that, to your question, there with the parts, is that, I think a general rule to follow, as Alan said, the robot itself can't cost more than a certain amount. But then I think the individual component cost can't be more than 400 or something.
This past season.
400.
And then,
I didn't
it
used to
has to
know
be, it has to be something that is available, like, commercially to everybody. It can't be something like, I work with NASA and they're developing this super special motor and then I'm gonna incorporate that onto my robot.
Well, not a motor, right?
Well, I'm sorry, not motor, but,
Anything else they make almost.
and,
It's the raw materials and also get
and then, when it comes to like other restrictions, most of it would be like power limited type stuff. So if it's super strong in some aspect of it, you might want to check it a little bit closer if that's something that's allowed. So like there's servo motors that you have some flexibility on those servo motors, but it's up to like 10 watts or something like that.
4, I believe.
Yeah, I forget exactly.
4 watts, and don't even get started on the watt calculation that they use because it's wrong.
Yeah. But they tell you what it is.
But it's not watts, but whatever. It's
But
Just use a small servo.
Just
and you're good.
ask them if servo's legal, somebody will tell you. But
For the most part, if it's under $400 and it's commercially available and it's not a motor, you can use it.
There's a max parts or components value to a particular robot.
right. And
4,000. 4,000.
it was 3,500. It's 4,000 now. However, you'll never hit it for various reasons. One, if it's ever been in the kit of parts at ever, even back to the 1992 kit of parts, it's $0 on your budget. So no one will ever hit that number. It's really, the cost accounting is silly.
Well, actually, there are some teams that have hit it if you have parts that you designed to be fabricated. But their first gives you, if you have to pay
that's
for
the other
fabrication, or they donate it, you have to count it unless the person who does the fabrication work is a mentor on your team.
Well, not even a mentor. As long as if they're a sponsor, if they're a sponsor.
Sponsor gets a little gray area.
But they're considered mentors as soon as they're sponsors on the team.
Yeah.
So we get all of our sheet metal is done by TXRX Labs. They're on our sponsor name. Therefore, anything they do for us and anyone who works for them is considered a mentor on our team.
That's a very important
And
feature.
all of that, all their labor is free.
Our sheet metal comes from 2 places. One is NEMA Enclosures here in Houston, and same thing. The cost of that pile of metal right there would be pretty expensive.
And Vanderglass does us.
And then IFI does metal for us.
Yeah, so getting sponsors who can do in-kind labor donations, or just as long as they're considered sponsors, even if you're paying them something, it still doesn't have to count depending on how it works. But yeah, most of the time, very, 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 very few teams ever have to worry about the cost budget. As an LRI, I've seen teams hand me, like you have to actually give a bill of materials, and I've had teams hand me budgets that were over the number, which I laughed at their mentor and told them they need to not have a student do this and give me real numbers because the prices are all wrong. And then they fixed it and realized that they were way, way under, and I was like, yeah, you should have not done that. And these are not new teams, but one of them was an extremely veteran team. But yeah, the cost accounting is almost never an issue for most teams. You'll almost never hit that number. I think all our bill of materials have, I think we hit 2,400 once is the most I've ever put on a bill of materials is what I had to cost account. And a lot of that is like, not even motors anymore. I don't even know what that is anymore. It was motors, but.
We don't run close. We buy a lot of raw material, but we count it by per robot, not for the total floor.
Right, exactly. You buy only what goes on the robot counts.
Right.
Well, the smallest segment you can buy it in that went on the robot. So if you bought if you have 12-foot sticks of it and you only used a foot, you're supposed to actually cost count the 12-foot stick. Unless you can buy a 1-foot stick, then you just cost count the 1-foot stick at whatever the 1-foot stick cost is. But again, none of that is really important. Okay, questions before we start pneumatic stuff? Anything? I will let Scott take it away.
Okay, so a lot of people asked about adding pneumatics to their robots. And so I'm going to talk about pneumatics as best I know them. And then at some point, somebody's going to say, no, that's wrong. And please do, because that's, like I said, that's how I've learned a lot of things. And a lot of the information I'm going to be giving you is from earlier, like, you know, when I first got started, and then it's changed over time. For example, there was a time when you could only use certain pneumatic valves, and now it's gotten very wide open on what valves you can use. Even, I mean, they used to restrict the flow rates, but I think they got rid of the flow rates somewhat.
Yeah, the CV's gone.
The CV's gone.
It's
Okay.
just
Just this
more.
past year.
Yeah.
Right, right.
We'll see what they do next year.
Okay.
We're pretty sure that's sticky from an LRI standpoint.
So anyway, and CV just has to do with the rate of airflow through the pneumatic valve. But they restricted it so that pneumatics wouldn't move too quickly, because parts that move too quickly can hurt people. But everybody's got ways of getting around that anyway. So I'm just going to talk through the parts of the pneumatic system from the hardware side, because the electronic side is totally different starting this upcoming year. And I didn't know what the difference was until just a few days ago. I'm not as much in the loop or in the know as other people in FRC are. You know, they've seen other pictures and things like that. And that's just because I figured when I need to know it, I'll know it. So I'll be okay. So I was gonna do this because I was a teacher. You know, I thought, oh, I could do this really cute little song like the compressor connects to it, and I'll do that. But I'm not going to do that. But it's going to be kind of like that, because when you build a pneumatic system, for me, that's how I build it. Is, I mean, I don't sing. I'll sing. I want to make sure you understand.
I was really hoping you sang while you
Okay.
sang.
But I will say, we're going up to IRI on Wednesday with 118 and 624. We're all sharing a bus, and I've set up a karaoke station on the bus, so it's going to be so cool. But and I can share plans with you later for that. So anyway, the first thing is, and I don't know, you're more than welcome to just come up here and stand around, because I'm not going to move very much, because I've got everything right here. And so you could come up, and we're going to kind of like put things together, because this is how I would do it. So come on down. I just need to be able to turn around and make sure I don't want to get something. So, and if you want to just sit back there, go ahead. That's fine.
One thing you might want to mention is, why would you even use pneumatics in the first place?
Exactly that.
Okay.
What is the point of
Okay.
it?
Let's back up a bit, I guess.
All right. So
Yeah.
why
Let's go
use
there.
pneumatics? Because here's kind of what this is what it's all about, and this is a pneumatic cylinder, and so this is what a pneumatic cylinder is. Okay. And so a couple of things about this is it's kind of considered digital. It only has 2 positions. It is possible to do kind of in between positions. There's different ways to do that. It doesn't work very well. So pretty much just pneumatics are, it's either this position or this position. And Alan probably has something on his robot that's pneumatic, like your launcher, right?
So yeah, actually this robot, everything except the drivetrain and the collector motors are pneumatic. So this up and down is a pneumatic cylinder right here. There's wings moving in and out based on these, and the actual launcher is 2 pneumatic pistons as well that move in and out, but you can't really see.
Well, the great thing about pneumatics is, if you can do something with 1 of 2 positions, they are really fast, and the power can be controlled fairly simply. Okay?
I wanted to make sure somebody said something like that.
Power is controlled by pressure and the diameter of the cylinder. Okay? You want a whole lot of power, run a 2-inch cylinder. You will have more than you know what to do with.
Yeah.
2-inch
But
cylinders almost
The
size.
issue with running that much air is every time you stroke, you need a large volume of air to push that much force through, so you need a lot more storage tanks. So there's lots of trade-offs. The
But
smaller
if
the
you need
cylinder,
that much
right?
power.
Exactly. But the smaller the cylinder you can get away with, the better in terms of competition standpoint. As you can activate it more often, it'll activate faster most of the time.
Last year, our climber was a 2-inch cylinder on both sides of the robot. We fired them one time. Because that's what picked our robot up onto the lowest bar, and it picked us up almost immediately.
Right.
Because we had big cylinders.
Right, but it does take a lot of air though. So
Yeah.
Scott and I's robot used wedge climbers that we just had small little pneumatic cylinders that would pop up, and then the wedge would be there, and then we drive up and climb.
Yeah.
So they work the same way.
We call them.
A lot less air. And the other thing about pneumatic cylinders is big 2-inch bore cylinders. All every pneumatic cylinder
They look like this.
most every pneumatic cylinder is going to be steel. It's one of the few places you really can't get out away from steel. And because of that, they're heavy. They're extremely heavy. So the thinner and lighter you get, the smaller under you stay under 120. And staying under 120 for a lot of teams can be hard. It's a lot easier now that we've shrunk the size. So brief history lesson, a couple of years ago, they shrunk the sizing diameter. It used to be 28 by 38. It's now 112 perimeter.
Is that going to stay?
Yeah, it's going to stay for a long time. That basically makes it so robots are lighter because their footprint's smaller. So in general, people are building lighter robots nowadays.
We are.
Well, we're still pushing the 120. We wanted to be a light robot.
This guy finally pushed 120. We did everything we could to make it do that, but
We showed up to Alamo 7.5 pounds overweight, so.
Wow.
We had a scale that was broken that we didn't realize how broken it was.
Scott, the one you had this year was on?
We went to Alamo, just 10 pounds under.
It's when you look at our robot, you go, where's all the weight?
so yeah,
Well,
there's
originally we had these side modules in there, and those added about 10 pounds to the robot. So they ended up coming out because we were rarely using them, like never. And so we took them out, and not only did that take our weight back down so we could add some more features in, but it also gave us space for some electronics and stuff.
yeah. And there's a reason to be heavy too. It's a design trade-off. So the friction equation, we'll get into it when we talk about drivetrains, but most of that is downforce, and that's robot weight. So this robot on the ground, when we competed, was about 153 pounds fully loaded, which is the heaviest robot that you can basically get, or very close. Our bumpers,
1 pound under.
yeah, basically about 1 pound under. So in the traction equation, it was very hard to move that thing. Also motor power and a bunch of other stuff to talk about, but there's reason to be heavy. But you want to not be too heavy, because you can't, 120.1, well, 120.2 is completely legal. 120.1 if you argue a lot.
Really?
254
Range of the
robot this
scale
year
can
was
be
about
wrong.
90 pounds, I heard.
Yeah,
192.
It was 5 pounds smaller. We were 185.
You were 85?
85 pounds this year. But it cost us, cheese beat us because we were too light.
Yeah.
We were faster than anybody. We could reverse and move around, but we lost due to the last match due to weight.
Right. So there's
For the rookies, 254 is Cheesy Boost. They're the world champions.
reigning world champs and pretty much undisputed best robot in the world this year by a pretty wide margin.
Oh, they got a good robot.
Yeah.
So anyway, the trade-off with pneumatics is that there's, for most teams, there's an initial cost of money, because you have to spend money to get some of these items that you see, and then there's a weight trade-off, because if you only need like one of these on the robot, then you can add a lot of weight to the robot in order to have this operate. Now, on our robot, we didn't have what nearly everybody else has on their robots, and that's one of these. This is a compressor. And so the compressor is what pressurizes the air on the robot, and we did ours off-board. So we had an off-board compressor. You have to follow the same rules for an off-board compressor that you do for it being on-board, with one addition. You have to have a second relief valve if it's off-board, because you have to have one on the robot and one on the compressor side.
In general, I'd say it's about probably no more than 5% of teams who use pneumatics have an off-board compressor. Almost everybody's on board.
Yeah.
The weight for most teams isn't killer. It's 3 pounds or whatever the light one is, the small one.
Yeah, so this is the old compressor from back in the day, and we use this for practice because it's heavy and it can handle the new compressor, which is this little guy here. The new compressor, when we go out and do demonstrations, a lot of times it'll get so hot that the tubing right here, well, the tubing here would end up melting because we didn't have it flown right either. So
And it
now
sounds
it's
like a
flown
nice
right.
little shotgun blast.
Yeah, it's hot.
I did see a lot of people use, put fans either on the
Yeah.
manual part or just blowing across the whole
Yeah,
thing.
and that's another place where Chief can help. There was a huge long threads about how to cool the compressor and up its duty cycle basically, because they're only designed to be run 10 or whatever, like 10 minutes out of every 90 or something, even less than that. It's 1 out of every 10.
You guys have 1 out of every 10.
Yeah, it's
The other
10%
advantage
duty cycle,
besides
but
weight, if you can design your robot with enough plastic air tanks, is you cut down your electrical load on your battery. And on some matches, that's the winning feature is your battery hasn't been running an air compressor all day.
yeah. And one of the things I'm going to talk about either today or tomorrow is going to be batteries specifically, because a lot of people fail to realize how important that is.
Yeah. We did not have a compressor on board our robot this
Right.
year. So
How much is the weight limit for this robot?
120 pounds.
Okay.
For
Because
the
I
without the
had
bumpers.
And without the battery.
50 or something.
Without bumper and without battery.
bumpers and without the battery.
So if the bumper is allowed to be 20 and your battery is between 13 and 14 most of the time.
So do you have your battery in that one right now?
No.
So that robot can't be over 120 pounds.
Right, and it's basically right at 100. Well, no, actually that's at 116 because it doesn't have, 118. It doesn't have the blocker pull on right now.
And at this time of year, actually, they can be 125.
We give, there's an
Because all the
off-season
off-season events
5 pound
allow a
bonus.
5 pound kind of grace.
That basically means you can fix stuff and not worry about your weight.
Yeah.
Is everybody restricted to the same type of battery?
Yes.
It used to be like very specific to batteries. Now it's about like 8 or 9. And you can get other batteries.
The same rough model number, right?
Yeah.
So it's all going to be the same size. They're going to be the same amp hour,
Right.
the same plug.
So
But
it's not,
any
you're not like gonna go out there and
manufacturer,
go, oh, we want to use a lithium battery
Yeah.
instead. You're
You're-
going to use the same.
you're using
lead
this-
gel
it's
cell
the-
that everybody else is.
MK MS17 type battery.
I ordered them from Walmart.
12 volt, 18 amp hour.
I order them directly from MK, but
Walmart sells spec battery.
we'll talk about batteries, but yeah,
Okay.
I'll talk about source and everything.
Sorry.
We'll get to that. Yeah. It's all right. There's a
No,
no.
Don't forget later.
Oh, absolutely.
No,
No,
it's
write
perfect.
down questions, and there'll be more than you want to know about batteries, because that's one of the things I did a bunch of research into recently. So we'll talk a lot about batteries.
So anyway, the first thing I think about on the pneumatic system is I think about the compressor. So got the compressor, and it's got to go somewhere on the robot. That compressor is kind of big. The other compressor is about half the footprint in size and probably half the weight. So then here on the compressor, you see this is a brass T, and there's a coupling, and then this is a relief valve. So you have to have this relief valve on the robot so that the pressure can't get over 120 pounds. So you set this, and the way you set it is you loosen, there's 2 fittings here, these 2, and so you hold this and loosen this one, and then you pressurize it up to 120 or over 120, and then you adjust this until basically it leaks when the pressure rises when it gets 120 pounds. Okay, and that way your system, the high pressure side can't be over 120 pounds. In pneumatics, you've got high pressure side where you store air, and you have the low pressure side, which is where everything's operating. And I'll show you that when we get, this is the high pressure side here, and then this is the low pressure side here. So basically storage is high pressure and operation is low pressure. So I've already got my relief valve stored on this one. So then the next thing I need is I need a coupling of some sort so I can plumb to the rest of my robot. So we buy our stuff from Automation Direct, and here we go. I brought lots of spare parts. So I'm all about, I used to be really, really, really cheap because our team was really, really, really poor. And we're not as poor anymore. We're doing pretty well now. So I'm a little bit more, I'll spend money a little bit easier than I used to.
Yeah, I'm still really cheap.
I know.
We still have money, but I still am really cheap.
Well, and I am too. I mean, like, I buy a lot of pneumatics. I buy them on eBay.
haven't gone that far yet. Not
No, I'll buy them on,
but-
because I'll get 10 solenoids for $100 or $150.
Yeah, it just depends on, I mean, a lot of that I'll do. We haven't had to buy pneumatic stuff yet, but yeah. We'll talk about part sourcing, but I hadn't been here in 2 weeks, and I went to my mailbox, and there was just a bunch of stuff from China because I order stuff in the summer because it takes like a month to get here, so.
So and I'm pulling off a piece of Teflon tape because this is what I was talking about me being cheap. This is an old fitting, and so the old fitting, there's a material on here that seals it when you screw it in. And this is a 1/4 inch NPT fitting, is what it's called. I have National Pipe Thread.
National
maybe is
Pipe
what it-
Taper.
What?
National Pipe Taper.
Taper. And they are tapered. You look at it and you think it's straight, but these have a slight taper to them, so the more you screw them in, the tighter they do get. And so a mistake a lot of kids will make is they'll just keep tightening and tightening and tightening, because if a little tightening is good, a lot of tightening is so much better.
That's
And
true.
On our intake system right now, we have all these cracks forming. Our intake system is made out of Lexan, polycarbonate. And they made a special tool they called Superbit. And when they used Superbit, what they were doing is, I should explain what I'm doing here. I took the Teflon tape and I doubled it over because I don't have any 1/8 inch Teflon tape. And now I'm wrapping it around the end of the pipe thread so that this will seal it when I screw it in. I've gone around kind of a couple of times there, and I'm going to pull it off. And I put it on the right direction, so when I screw this in, it won't unthread the Teflon. Okay.
If you do manage to find some 1/8 inch Teflon tape, buy 10 of them.
Yeah.
Because you won't find it again.
So I did the 1/4 inch NPT, and I need an 1/8 inch NPT. So I'm going to reach in here, and I do have an 1/8 inch NPT, and I put this.
And after you buy it again for yourself, post on yourself like other people buy it. After you buy your tablet.
Yes.
Here's an 1/8 inch NPT. It's also a straight fitting, and it already has the material on it. I've got some others if you want to see, so I'm just going to screw that in here.
So this is a good point. When you buy your fittings, I buy them in 1/8 inch and 1/4 inch. I buy a bunch every year in 1/8 and 1/4. I buy them in the same place Scott buys them from. And I'll send in a $300 order at the beginning of the season, and you don't know what you're going to need, but I guarantee the one you haven't got is the one you need.
I keep trying to find different ones they make, and then we just have a small store of those. I did find one of the cheap ones, so I'm gonna go ahead and use the good one because I'm not gonna take any more of your time up doing that threading. So I'm screwing this one in, and I grabbed some wrenches out of Allen's stuff here.
In terms of some of the part sources too, one of the places, most of the pneumatic stuff doesn't come in the kit of parts anymore. It's all in First Choice, which is a virtual part of the kit of parts. So at basically some point in the fall, they'll announce a shopping period where you can go look at what's going to be on First Choice. They'll announce how many credits every team gets, and then on the day of, they basically open it up and say, all right, people can go buy, you can buy whatever you want, all you do is pay the shipping costs. That's where all the pneumatic stuff is. So all the rookie teams, if you want to get pneumatic stuff, it's all on First Choice. We end up getting, like, somebody on Chief will end up doing a value chart and basically say, this is what everything's worth per credit that you're spending or whatever. Pneumatic stuff normally comes out pretty high, so all of like the tube fittings and things we have thousands of now that we got for basically free from First Choice because that was the best value, so we just kept saying, yeah, we want those. Plus
we try to
tubing.
get on First Choice really early and spend our credits on a few big items, and because it used to be those were really the good deal.
Yeah,
The
it just
big
depends on
items.
it depends on what you can get. And they're working and improving that over and over again because some teams, if you got there first, you could pull away with $2 to $3 grand worth of stuff.
Yeah.
That was what my 2013 pull was. We had like a classmate and a C-Rio and a bunch of other stuff that was basically free that shouldn't be.
Using quick connect fittings where the hose connects into the fittings. If you have any adults who come from like a trucking industry or something with pneumatics, they will tend to use fittings that have brass fittings with ferrules, which will not leak, and they cost a lot more money, and they weigh a lot more. So,
That's why I didn't even know
from-
about those.
Right.
Yeah, so you want to stay with quick connects.
Yeah, all of anything you can put on that's plastic and not brass, you're better off most of the
Okay,
time.
think about the quick connect fittings. You push the tube in, you feel some resistance, you shove it in some more, past an O-ring. That's what seals it. If you just push it in until you think it's in, it's not in.
Yeah, you'll feel some initial resistance, and if you want to try it, you're welcome
Yeah,
to just come in and plug it in and see what it feels like.
Yeah, give it a shot, because
You just plug it in there.
You'll be showing your
You'll feel
students
it.
how to do this.
You'll feel it. You know, you'll hit the inside, and then all of a sudden you'll feel the resistance.
And make sure your tubing is cut as straight as possible.
That's
Yes.
right.
And there are tubing cutters. There's a real cheap one available from McMaster, about $5 or $6.
Yeah, Automation
for a
Direct
cutter.
too. When you buy your fittings, it's $4, I think.
Because
They have-
last year we were chasing those and I found that we didn't have to undo some pneumatics.
But you also don't want to get a sharp bend coming out of the city.
Push them in.
That's
And then
where the
pull it
difference
out.
come from.
Press that in.
Right. And a lot of times if we have a leak on the robot, one of the things I look for are places where the tubing goes in and then it's like bent like this. Because there's going to be a leak at that spot. So you want to make sure you have enough tubing that it pretty much goes straight in.
Right.
To take these off, and this is a real pain if you have kids that, like, especially rookies,
I think
you tell them,
demanded.
hey, you know,
Demanded
let's disconnect the
my kids
pneumatic
do that.
tubing.
That was great.
They
They're
just
like,
pull
"I won't do it."
and pull,
You're not
and
gonna
ruin
run
it.
the field
You have to
until you
pull
make it
this
take
ring
specialist.
down, and then this slides pretty much straight out. If there's resistance, but if you don't do that, you can pull all you want. If it does come out, then this will be removed for sure.
For the flashlight and
So
the tubing.
especially with my first year with the mental pneumatics, and I learned that sometimes the kids would use quick disconnects that didn't have like a springiness in them, and so obviously they would like work. And is that just the O-ring that's missing in them then?
I don't know.
It's, it comes out.
Yeah.
On our,
Be
on our,
aware-
We hadn't used any previously.
Be aware that these quick connect fittings, there's a metric and an English. The 6 millimeter is almost a 1/4 of an inch, but not quite. And so every supplier has different colors. The blacks are English. I can't recall what color they have, I think it's blue, is metric. These black fittings. So,
what about this red one?
so that's a red top. No, the body is blue for the metric.
Oh,
For
okay.
SMC, SMC has a metric fitting and an English fitting. So if you read the stuff like I do, you can figure out what color is the one you want to order. And then you make sure if you have any of the other color, you find them and you throw them away. Because if they get on your robots, you are never going to shove a 1/4 inch tubing in a 6 millimeter connector. Ever.
I'm going to show you some lights a little bit later, because I always like to have pretty lights on the robot. And
Lights are very useful.
they do serve a purpose.
Yeah, mine are
But-
slightly less pretty and useful than Scott's, but I
well,
still
they're-
like
right
mine.
now they're pretty much just pretty on this year's robot.
Oh, you took off all the other stuff, right?
But they'll be so anyway. They hooked up power backwards to a set of the lights, and so they took it and they wrapped them up and they put some tape on there and they wrote bad on it. Okay, and I said, so I saw this the other day. I saw this strand of lights and I said, so are those lights bad? And they said yes. I said, so why do we have them?
Because your kids are learning from me.
Oh.
Do you know how much stuff I have back there that just is labeled bad?
So, I said, why do we have them? And they said, well, I don't know. I said, are you sure they're bad? Yes. And I said, okay. And so I took them home and I checked them to make sure. But if I hadn't checked them, I was just going to toss them in the trash. If it's bad, there is zero reason for it to hang around.
It's nice to know I'm not the only one having that conversation.
No, I have lots of bad things. But we end up using it for things, so it's fine.
It's not bad.
Yeah, it's bad for a certain purpose. It's just not bad for others. Like we have a lot of sidecars that are bad because like their signal light is bad, but it does everything else. So,
Well, and I've repaired the sidecars, the little voltage regulator inside. I've replaced some of them. So digital sidecar, you don't have to worry about that.
Well, for the old robots you will, but it controls all the outputs to the motors and things. Well, it is the connection for them. The Serio's controlling it, but there's a whole nother box part of the reason we're going to a new control system is to simplify all that into one little panel and be right. But you'll see it on the old robots.
Our biggest problem this past year on our robot was where do we put all the electronics, all the control systems, because the footprint was so large. And James, our lead design mentor, he never allows for it. And so it's kind of like, well, we know we'll find space for
That's
it.
like the one thing I allow for. Like the entire robot was built around the electrical panel.
We'll get to that
He's
later.
mechanical.
We
So anyway,
we have no room.
so here's my next piece. This is a pressure switch, and what it does is right now the switch is closed inside. Yes. So internally the switch is closed, and then when the pressure gets high, the switch opens, just like you didn't even have it connected. Okay, and so what this does is this is feedback to the computer, so it knows when the pressure on the robot has gotten to about 115 pounds. Now that pressure varies just a little bit from sensor to sensor.
Correct.
So we will, on our competition robot, we will have the one that's 120 pounds, because that's what you're allowed.
We haven't gotten to, but it's been on our list of things to do is find a 120-pound pressure switch because they're not adjustable. Don't try to adjust them.
Yeah.
People will break them by trying to adjust them. Don't try to argue that a adjustable one is the same as a non-adjustable one that's in the kit, because it's not, and you'll lose. But you are allowed to sit there and find a 121 if you want to buy a bunch or get a bunch over the years. The difference for most teams is basically 0 between 110 and 120 psi. It won't matter for most teams. It matters for some. If you, world champion level, trying to win a match at a regional level.
At a regional, what are you saying? So anyway, so I'm going to just set this down over here because I'm not going to place it where it shows there. I'm not going to place it in this location. It can be anywhere on the high pressure side. So it can be anywhere from here to this spot right here. The next thing on here is a storage tank. And this is an old storage tank. I don't know very many teams that use these storage tanks anymore. I brought it because I want to get rid of it. In fact, I want to get rid of it so bad that when I'm done today, I might just let somebody take it with them. Take it away.
We can add weight if you're wanting to make
If you, yeah, we've never been in that situation.
We were last year.
So, so anyway, so this is an old storage tank. It used to be you were limited in what size you could use, and the number of tanks and stuff. Now it's gotten wide open. So here's Alan's got a couple of these. Who makes these?
These are New Air.
New
So
Air. That's where we get ours.
There's a ton of controversy about plastic tanks. If you get into Chief, there's a really, really long post. There's a bunch of discussion on the LRI forums and all over the place because they have had plastic tanks explode. The only plastic tanks to explode are made by Clippard.
And they were the ones that were distributed on First Choice.
The First Choice last year, because they had thread fittings that had problems, it was also, as far as I know and as far as anyone's ever been able to tell me, the first plastic tank Clippard had ever made. New Air's been making plastic tanks for an extremely long amount of time. They've been using them in FRC since 2010. I believe the Thunder Chicken started it. Copioli corrected me at one point.
217.
Yeah. Copioli's a mentor who's been around for a very, very long time in First.
And he's the
president of Vex Robotics, who makes
Robotics,
Victors and
Innovation First.
People are all over the place, but yeah. But basically, those tanks have never had a problem
Alan's
with anyone
name dropping
knows.
right now.
I am, yeah.
If you don't mind, one of the big problems, I think, if I remember right, the reason that it exploded was that it wasn't mounted properly. People zip tied it to the robot, and then they zip tied it too tight. They have specific clips
And we have
to hold it in place.
the clips are on there, and we always mount with the specific clips. The clips are $1.50.
Because otherwise, it's under a lot of pressure, and if you're pulling a zip tie real tight on it, you can mess up the structure.
We don't use the clips. We do use, we mill brackets, and then we zip tie them into the bracket. So.
We've zip tied them, we've used brackets.
Right. So currently they are legal. There may be things changing in the future, possibly. I hope not. But besides for banning the white clippered ones, but
much larger.
There's also the problem with how you were talking about the over torquing.
Right. Well, that's actually what I was just looking at this one.
the New Airs don't do anything though. You can over torque it all you want. Like I don't. Yeah,
I
that's.
think that's one reason they were saying.
But
so what happens if you over torque this one?
the New Air, it doesn't do anything.
It doesn't strip the threads.
As far the New Airs have, we've had kids who got really aggressive on them, and I was like, oh, that doesn't look very good, and we haven't had a problem with it.
Okay.
The clippered ones, if you do, you'll start seeing cracks.
Okay, I've got girls I've had girls strip those things.
Okay, we never had, and I've had kids.
Well, it's two different things. Strip the threads out and cause cracks.
Right.
You can strip the threads out.
Right. Well, that's what Scott's talking about.
Yeah.
That's what
You start deforming those threads enough.
Yeah,
they'll
you can figure it out.
It's
Yeah,
a plastic
it's-
thread and a brass body.
Yeah.
Right, you can definitely make it happen. There's just a matter of whether,
But
the
forming
person
cracks
doing
from
it, we've
is
had
two different
kids.
things.
So I always tell my kids when they're putting these in, this hex part should not seat against the
Correct,
body.
yeah. And then that
there
stuff-
should be a space in there.
That's stuff that should be trained.
And
Curiously,
this
that's
one
what I
doesn't
told
have a
them.
space. And I'm
And that's not one that goes on a competition robot either. That's from
And then
several
Alan's got
years.
he's got his pressure switch attached to the tank, and that's a great place.
That's a good idea.
Yeah, that's
Find a place to
yeah,
have
we can
that.
Just
talk
so I'm
about it.
100% clear, the pressure switch's whole purpose in life is to shut off the compressor before you go over.
Before you
Turn
get over
on the
120.
compressor when it's too low.
And turn off. And turn off when it's too high. Right. So and it has
So all
built
it's
in.
doing is controlling compressor on off.
Yeah, so it
if
turns-
it's on board now.
If you have a
Yes.
compressor in your garage and you're running your air hammer or your nail or whatever, when your compressor kicks on, that's because this pressure switch has sensed
Right.
that the tank pressure is falling too low. That's all that thing is doing.
But it's also when it's off board as
Right.
well. No,
That's
so-
why you want one that doesn't shut off till 120 because
Right,
of-
but
right.
you also have to use the pressure switch whether the compressor's on board or off board. It has to be wired in, and the serial still has to be controlling it. That's part of why. So you can't just have somebody go fill up with a compressor to 130, whatever they want, or a shop compressor, which there's a bunch of debate about that too. But we're not going to go into the shop.
Move your pressure switch as far as you can on the high pressure side, away from the compressor. Compressor puts out a pressure ray.
This is true.
So when it comes out, when you're at
This is also
120,
true. I don't
make sure
put
that
it on our
20
compressor
meters away
anymore.
above that.
Yeah.
And by moving it farther out, we got an extra 5 psi into our tanks.
We put our pressure
Write that
switch,
down.
Never thought
we
of
put
that.
on the upstream side of our regulator for that reason.
Yeah.
Yeah.
We plumbed it in with brass
Yeah.
right to the regulator.
But that way the tank is like a muffler and
Yeah.
it absorbs the
Okay,
pressure.
so
weight, and
we
that
put ours on always on an opposite side of a tank so that you don't get that pressure wave.
I'm alert. I just learned.
The other thing that isn't on here but has become legal in the last couple of years that is useful to know is you can have pressure transducers as well, which are sensors that all that does is tell you if you're below 90 or if you're above 120 basically, or if you're at 120 or whatever the actual value is.
I didn't bring the train. I had that in
There's a
my
transducer on the robot. We only own one, so we move it back and forth. But the transducer will tell you actual pressure, so you can do fancier things if you want to know that you don't want to fire something unless you're at a certain pressure. You can tell it, things like that.
You can replace the pressure switch with the transducer.
No,
No.
absolutely not. Absolutely
That's
not.
the president first told me that. You could.
Absolutely not. I will fail you immediately if that pressure switch is not on your robot.
It also messes with the code because
Your pressure switch absolutely must be on it, and so much so that the next control system, it's not even, the serial doesn't even see it. The pressure switch wires directly into the pneumatic control module that holds that powers the compressor and everything. That pressure switch will be there at 100% of the time.
But that's not what the rules said.
And I promise you it's what the rules say. And Al Skirkowitz has also confirmed it many, many times. We have nice secret meetings in New Hampshire. Like, it's quite fun.
All right, so the next thing I have a bunch of I have some other things here to attack. So I've got this pressure sensor or pressure gauge. Tells me I can read it, and then still haven't attached this. So right here I have something that we started using a couple of years ago, and we just buy these from McMaster Car, and they're little manifolds. And so this one has 5 1/8-inch NPT ports, and then 2 1/4-inch ones. And so I can feed in my pressure here on the end of this, and this one is going to read the pressure on the high pressure side. And by the way, I'm using black tubing on the high pressure side just so it's easier for y'all to tell which side's high, which side's low.
That is something useful in all robots.
To do that anyway.
And it depends. Sometimes you have to make a design choice. So I've tried to get my kids to do that this year, and they were like, "No, white tubing everywhere," and I was like, "Okay," but they overruled me. But yeah, you can.
Our team colors are black and black, white, and then our accent color is digital sidecar blue. A lot of teams don't know that. Which happens to be this right here. So that's why I have this. So this is our accent color. You see this on our robot. We're trying to be fancy. So let's see. I need to put this pressure switch on, and I would do the wrapping with
new stuff's all done.
I'm gonna go ahead and do that, because I actually do plan to pressurize
There's
this
a little bit of green
when we get
accent.
done. If Al will let me, he is a robot inspector, he may not, because I'm not gonna have
It's
everything.
a dark gray.
Wire.
There's some green instead of like the whitish gray.
Oh, you got a power, you do have a power source back there, I saw that.
What?
So anyway, I'm putting my Teflon tape on here. When I'm putting the Teflon tape on, I want to make sure that there's no possibility the Teflon is going to come off in the system anywhere. So I put it on the threads, but I never have it go past the threads on here.
That tape will mess up a solenoid or a switch really nicely.
Rule of thumb, the thing is you never have the tape closer than, is either one thread or two threads from the tip.
It's a good rule of thumb.
The rule of thumbs in applying thread to tape I have heard numerous times from many people. Find something that works for your team, ask somebody else, make it work, but the number of like whether it should be counterclockwise, clockwise, whether it should be away from the tip, if it doesn't leak and it doesn't break anything, go with it.
Well, we had essentially, we ran, I've said this like 5, 6, 7 times now. We did not have a compressor on board, so we would go out there on the field, we'd have our robot all pressurized, and sometimes you have to leave it for a little while because, you know, they were making announcements or something. And our pressure would stay up there, that 115, 120 level. It wouldn't drip down. So, I mean, we're not gonna have a leak on our robot and not be trying to find it, so. Let's see, so now I've got this other end here. The problem is finding it.
Yeah, there's several ways to find the leaks. So the way that one way is to have a bunch of tanks and a big compressor and not care that much. That's what our strategy this year. The better way, I don't know how you guys find leaks. Do you guys use soap or what do you do?
Soapy water.
Yeah, you take a little bit of soapy water and you rub it around all the joints and it bubbles. That's the way to find the really hard ones.
I have never done that.
You can find somebody on your team will become like the pneumatic whisperer and he'll quiet everyone down and listen for it, and then they'll just find it.
Usually
right.
if you shut off everything on the robot, the kids can hear it because they're hearing.
Yeah.
They can hear that high frequency.
And one guy will literally just be like, you turn it off, and he's like, oh, it's over in that cylinder. I'm like, you weren't even looking at the robot. What are you doing?
Yeah.
Like,
Just busy cat.
Also, you can buy electric stethoscopes or ears, and the amplified, you can use that to follow real small.
Oh, that's a good idea. Never thought about that one.
Something we've done is we put a pressure gauge attached to a quick connect fitting, and we connect it to a part of the robot safely, so we can bleed the air, and we prove a system that'll hold 120 psi. And then you mark a piece of tape to the point where it's good. And you keep working your way downstream until it no longer holds. And then you know that your leak is between here and here. Then you have to do a little more diagnosis, but that's how we do it. It's kind of old school, and it's very low tech. But it does work.
It works, yeah.
Basically,
Yep.
split circuit tap, keep working.
Okay, so here's my, so I got my pressure gauge. The next thing I'm going to is I'm going to a pressure regulator, and I think it has to be a relieving regulator.
Yeah,
It's
and
a
all of
primary
them,
regulator.
and amazingly, all of the yellow ring ones nowadays, you can get them that aren't relieving, but every one that's an FRC one, a normal one, is relieving.
Yeah.
Even though they trained us wrong for a really long time.
I mean, I would have people tell me, this one doesn't relieve, and then I would look in the description, it would say it relieves.
Very, very, very high level LRIs have told me the same thing. And I for the longest time thought it didn't relieve. I was very wrong.
Why don't you tell people what relieving means?
Right.
Yes, so the pressure, so this should be set to 60 PSI here. If it's not, I'm gonna adjust it. And the way I adjust it is I pull this yellow ring out, and on some of these it's black ring. So pull the yellow ring out, and then I just turn this until, the gauge is gonna read 60 PSI. I can't be over 60 PSI. Now, on our robot this year, I think we ran about 40 PSI or 45 PSI. And the advantage of doing that is that what was stored in our tank went longer if we were only using air at 45 PSI. Because, 120 PSI at 12 cubic something, whatever.
What do I need?
If I cut the pressure in half, it would be double the volume. So if I cut the pressure by a third, I'd be triple the volume. That would mean I'd get more use out of my compressed air.
So what is a relieving regulator?
So what the relieving regulator does is, if for some reason, like let's say I run my robot into something, I have the arms out, I run my robot into something and it pushes the arms back in, suddenly the pressure on this side, which is supposed to be 60 psi, which is supposed to be 60 psi, suddenly goes to 80. This relieves it, lets it go to 60. Okay, not all regulators do that. Now all the ones I've ever used do, but not all regulators do that. They only control the pressure going one direction, but this one will relieve that other low pressure side if it gets too high for some reason.
Is this relief digitally controlled or somebody has to manually relieve it?
So while you set it, oh no, it automatically relieves itself. It's just the way it's put together.
And there can be reasons to not have a relieving one that teams will use because you want to build up that pressure. You want it to fight back harder than.
But you can't use one, can you?
Downstream of the 60 psi, you can.
Oh, you can.
So at the 60, your main 60 psi regulator has to be relieving. Downstream from that, you can have one regulated to 40 or whatever and not be relieving, or 59 and not be relieving.
As long as somewhere in the system you've got that one that relieves at 60.
What am I looking for? So while he's doing that, brief backwards on pneumatics in terms of some of the theory so that we're not losing everybody.
There we go.
Pressure is force over an area. Measured in PSI. Convert pressure to force. That's our whole goal here with pneumatics. This is how compressors increase pressure in the system. Good. Storage air, all volume. All you're worried about is volume, cubic inches, as much as possible for the most part, as weight allows. A lot of people's last bit of weight is adding more storage tanks. There's a lot of people I've seen. The biggest I've seen has been 14 or 15. It took 7 minutes to fill. Right, so that's the inside of a pneumatic cylinder. That's what it looks like. Air goes in one way to force it out, or back the other. You can also get spring-loaded cylinders. I have a couple of or spring return cylinders. So this port will be gone, and there's actually a compression spring on the inside of here. So when you push air in, it goes out. When you let go, it comes back and retracts automatically. That's a nice way to save air because you don't have to force air out the other way. So on that robot, we have 4 cylinders that push the wheels down. The downward force is all air. Then when we release, they just retract with the springs that are internal to them, and the wheels come up on springs as well. So we use half as much air to shift as we would if we had that doubled. Look at that. I also drew that spring in PowerPoint. I'm very happy with that.
That's pretty good.
Yeah, I was very, very pleased with myself. Okay, we're not there yet. All right. With a spring, what do you mean? So the spring return cylinders, you'll have slightly less force going out just to fight the spring. So you have to calculate the force of the spring. If you're like right on the edge of how much force you need for some reason, you need to make sure to calculate the edge of the force of the spring into your equation. Part of the reason why we actually had to up the cylinders on that one because we didn't do math very well when we were lifting the entire robot by those 4 cylinders. It turns out a lot of teams don't do math very well when they do that. There were a couple other teams who didn't shift right either this year.
Remember that these things are made for industrial applications to run for years in a part? We're running for 2.5 minutes, 11 times in a competition. I have never, ever, ever worn out a part on a robot. At the end of a season and then through the summer, I've had some things get real wobbly, but I've never worn out like a cylinder or anything that's industrial. Anything that we wear out is our own bad construction.
We bend and break.
I was about to say we break stuff. We don't wear
Well,
it. We don't not pneumatic cylinders.
You ever filled a cylinder?
We damaged the pneumatic cylinder.
But I mean, using it like just from use or from impact. I've never had it from like I was sitting there and it failed because of like cycle count.
No, never from cycle count. No.
Like I've definitely I've broken. We've been on both ends of that. Our robot has either
The year
broken
we had
people
the
or
mini robot, we pushed our robot out with the pneumatic cylinder and the rod bent.
Gauge here, well, or is that
So on
the whole thing here?
On his, this is the one of these is the high pressure. So this is the high pressure side, and this is the low pressure side.
Okay, so in the middle is the reliever.
Right.
is the regulator.
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 That
What
relieves.
is the, yeah.
see this arrow right there?
Oh, okay.
High pressure side, low pressure side. Follow the arrow. First, find the arrow.
Yes,
Pardon me.
there's always an arrow, and it is tricky to find. And the what you're actually looking for is the side opposite the arrow, because that's the inlet. The other three are all outlets.
Right. And the older you
on
are,
most
the more
regulators,
difficult it is to
yes.
find the arrow.
On the ones with the yellow ring, it's the arrow is the direction of air flow.
But the other two are also flow. So the opposite side of the arrow is in. The other three ports are all out.
That's correct.
Oh,
On both of those
There's only-
regulators.
there's only
right.
one
There's only one
import.
import, and that's the back end of the arrow. That's what you're looking for. So you don't want the thing it's pointed to, because actually the thing it's pointing to and the things to the left and right of that are also outs.
So I've got this air now, and here's where my pressure would be coming out that's low pressure. So I'm going to get a blue hose, because that's my low pressure side.
You said this is blue hoses on the digital side. What do you mean by digital side?
So this side up to here, this could
Digital
be-
sidecar blue is what she's referring to.
Oh.
Yeah, because you said white is the high pressure side, white is.
Blue is low pressure.
I'm just using this to demonstrate.
So-
I could use black for everything.
Right.
In fact,
The-
on our current robot, I think it is all black.
Right. The digital thing was just a descriptor of the type of blue, not of anything special.
Yeah, this blue matches my deep color.
Matches your
It's
shirt.
like an,
There's a blue in your
it's
shirt.
like an accent.
Yeah, that's the accent
It
color.
really is like an accent color for our.
Right. It's on your left sleeve.
Yeah.
Okay.
And it's actually on our wiki where we keep all our data that keeps our team from year to year. So we get in an argument about what color it's supposed to be. So this here would go to a solenoid, and I have the base for a solenoid. I have that right here. And so this is where the air comes in. And this is where the air is going to go out, and that's going to go to my pneumatic cylinder. One of these is A, one of these is B, and I can choose which one I want to be, A or B, depending on the type of. I like to use these as much as I can because this is this is a spring-loaded one. So what happens is I just have one actuating pair of wires here, and so when you apply power to this, it's going to shift the valves inside to a certain position, and that's going to let air flow from here to, I think it's to B, is where it would go. I don't know. Sorry. So it would go out B, I'm going to say, and then when you take power off of it, it's going to go back to the other position, and so the air will go to A instead, and port B will exhaust, and it'll let the air go out of that side. And the other, when it's in the B position, port A is exhaust for that side. So that's what the solenoid and the valve does. And so this part here is actually, I kind of consider this as actually the valve itself, and then this is the solenoid actuator part, because this is where the electronics are that pull the valve back and forth inside. Now this one just happens to be taken apart because I looked at my system and I had a 24 volt solenoid and I wanted a 12 volt to be able to demonstrate to you. Because on the robot you can have 24 and 12 volt solenoid systems. There's 24 volts available on the power distribution. And so I don't know exactly how that works on the new pneumatic.
They'll be the same thing. You'll be able
Same
to
thing?
feed both ways because we use 24 every year because
I'm so
we have a
glad I
bunch of
did.
solenoids for it.
Because I'm learning things.
Is there any concern about, because the 24 volts is where the C-Rio power.
Currently, yes.
powers run, right?
Yes.
So you guys never had any concern about?
No, it's actually it's in the rules you can only pull 10 amps from it or whatever, but that the 24 volt thing on there was designed to do solenoids too. Eventually, they worked it out.
So this one happens to be taken apart because I was switching it out, and the other one was a double active solenoid. This one has two actuators on it, and so when you activate this one, it would slide one direction. When you activate the other one, it would slide back. So I like using these because it only takes one control line, powering line. It's sort of like the same thing because that's how you control it, is by powering it. But if you have something on your robot and you want it to stay just like it was when the match ends, you need this one. If you're okay with it going back to like a default state, then you can use this one. And so if you look on our robot, you'll see a mix of these. We try to use these as much as we can, but we use these when we need to.
So is it called double action?
It's a, I don't know, dual action solenoid.
Single acting or double acting.
Yeah.
Yeah, and then so also in solenoid, when he was talking about the flow rate stuff, so to be able to launch balls this year using pneumatics, a lot of teams did a lot of research into solenoids. So those are what the standard ones, and those have CV ratings that are much lower. These guys seem huge, but they're also legal and have a much higher flow rate. And it's a single one too. But yeah, that's the same idea.
Okay,
but
let me see that for a second.
And
What?
we'll help you get you.
That's an automation direct one.
What you're going to look for when you go buy these things, and if you're not in the profession, you have no idea what to look for, like me, it's a 5-port, 3-4-5, 2-way valve. Okay? Every place I've looked to buy valves, there's always something about the number of ports and the number of positions. And I've learned that the hard way.
Yeah, and you want them to be 1/8 inch port, because that's the new standard
This
size.
year.
Right, this year. And that's
Read the rules.
Read the rules, but 1/8 inch port, for most of the time you'll want 1/8 inch port anyway, because that's what all our fittings are and other things.
You
But
can't have, they can't
Well-
be ordered. Oh, I guess on the
on the
solenoids.
solenoid, right. That's how they're limiting flow this year, was they limited it to 1/8 inch port.
Right. On this one here, it was limited by the port size. In the past, they limited it by the CV rating.
Right.
You could have a 15-inch port, but it was still a .34 CV.
Right, but then it sold that they were related, which is why they eventually got rid of it, because you can't get more than a certain CV through an 1/8 inch port just because there's, it's a physical volume that you can fit through something.
But the thing is, with pneumatics, you must be one with the rules.
Yes.
Otherwise, someone like him
Yeah.
is going to fill your robot an hour before you want to compete.
But the biggest thing when we say we fill your robot, what happens is we find the solution to fix it. And we find the solution to fix it before your first match at your regional, almost 100% of the time.
Somewhat depends on the inspector that you're dealing with.
Correct.
Yes.
Find the LRI. They've all been doing it for a long time. They're all pretty good.
It depends on the
at
inspector you
Alamo,
get.
Past 2 years, we've been incredibly unfortunate, and keep getting inspectors that it's like their first time ever, and so they spend an hour learning to inspect on our
Right,
robot.
and like part of that is doing the service, and they have to learn on somebody's robot.
I
It's
know.
better to learn on somebody like your robot. There's going to be less problems than on somebody who they need a lot of help and need to be fixed. So I spend my time with the rookies and making sure that everything's right, and we get them out to their first match. You can sacrifice a bit of time. I mean, my team takes the hit too because I have lead inspectors trying to break my robot. So, like,
Oh,
Okay, please understand that just because you get inspected in one place, you're okay, you can go to the next regional. Because we've
Doesn't
been
mean
at
you'll
three this
pass.
year, and it took us an hour at every
It
single
takes
regional,
a very
and
long time.
Depending on who that inspector is, they have their little areas that they really inspect. And just because it passed at Alamo doesn't mean it's gonna pass at Dallas, and just because it passed at Dallas does not mean it's gonna pass at Lone Star.
so the checklist is out.
We didn't
Make
change anything.
right. Try to read as much as you can. Try to read as much as you can to the checklist. Make sure it's right. Be as good as you can be, and then work with the inspector. Actually, have your students work with the inspector. Well, basically, when inspection happens, especially for me, since I know most of the other inspectors, I leave as fast as I can. Like, I'm not anywhere near the pit. It's all with the students doing it. But just have them ready to go. Have them walk it through with the most knowledgeable person on your team or with an inspector beforehand, and you can make it go easy. Be nice to the inspectors. They have a really hard Thursday. Like, they're doing a ton
I
of
love
teams.
inspectors.
Yeah.
But when we were at Champs this year, we several different places, and we were having issues with them leaking, and so we'd switch them out, go with another one, go with another one. And so, you know, if you've got a leak in your system, that would be a place to check, would be to check that dump valve. I don't know why. Maybe I just was unlucky, had a couple in a batch that weren't very good or something.
This year we had a problem. We had one of those long handle dump valves, and we had the handle rotated over out of the way of our chain. We had a pneumatic line running nearby that would vibrate, and it kept hitting the handle, and that's why we were losing air pressure. It took us forever to find that.
Yeah, we had our dump valve sticking out in space a little bit, and so it
Ooh.
could get hit, and so we moved it. Our robot will be here tomorrow
Yeah,
on the way
that's
down
the
to
same thing
NASA.
with ours, same thing, we gotta get,
Yeah.
and they don't tolerate it.
I'll show you where
That's
that.
why it is now, is that
I'll show you why. Yeah, you'll see where it is. It's not really mounted that well yet. So.
What's zip tied?
Hard, the valve for the release thing.
Don't do that. Don't do that. Please don't zip tie your valve closed.
Well, the inspector saw it. It's
That's
supposed to be-
Oh no, that's illegal.
That's terrifying. The whole point of having a dump valve is if something's going wrong, you can dump the air quickly for safety reasons.
That's what I said, in different
Push switch, dump switch.
So one last thing I'll talk about here, and then we can see if we can get this. We want to get this powered up or something and operate it, because I do have a 12-volt solenoid on here. The solenoid is a really old one. It doesn't have wire that plugs into it. All the ones we have now, they use these plugs on them instead. But these are some really old first ones. So, we started using manifolds, and this one's not legal because, well, actually it probably is now. I don't know. But anyway, the idea of a manifold is right here. This is places for two of these solenoid valves. We keep these in stock, and they're 6 and they're 8 ports on them, because that's how many solenoids we usually have on the robot. And so it saves some weight, because you can just like have a bunch of them all together, and it saves some space and makes it easy for mounting and everything. However, I noticed that 118 uses solenoids where the ports are basically built right into the body of the valve. And so they essentially don't add any weight. So their weight is even less than it would be for using a manifold.
Yeah,
Now, what do they do?
Regular standard one.
So what the manifold does is it's basically
No,
right
I don't
here.
have a manifold. What does
Oh.
118 do?
So 118 has somewhere the ports are built right into this. Not
Yeah.
You don't have to have a separate.
Yeah, they
Yeah,
have
that's what we buy.
They have even tinier ones.
We've never bought
Well, they have
manifold ones. We
tiny,
buy
tiny
ported
ones.
ones.
So like
Well,
we use
this-
those. We use
probably
those
just when I
types.
started, that's what we had.
Right. So
Okay.
we use what are pictured right there, which are basically the same thing you're talking about, except
Yeah.
118s are slightly even more different. They use a different model number than I've seen a lot of teams use, because it's tiny.
That's a Festo.
Right. That's a Festo. The ones
Yeah.
that 118 use are tiny.
We've used SMCs historically, and this year we used this kind also because the high flow rate.
Right.
And those are monsters, but they.
Yeah.
Well,
Yeah.
we've actually had. I brought. I said that was going to be the last thing I was going to mention. I brought. I couldn't find one of the fittings, so this is an inline version. He's got one. This is a flow control. So the way this works, and you have to. Most of them they work on the exhaust side.
The meter out ones do.
This one is exhaust.
Those are exhaust.
Yeah. So, and there's special schematics for pneumatics if you want to learn something really useless.
Or you can stick your mouth up to it and blow and figure
Oh,
out which way
really?
it goes.
I never thought about putting my mouth on a piece of metal. So.
It's not very good. Don't do it often. You get moisture into your pneumatic system.
There you go.
But if you
But
don't
you're
know
gonna
which
get in
way
there
it
anyway.
goes,
You're
yeah,
gonna get in
I
there.
just emptied a bunch of water out of a tank, and I was like,
Yeah.
where'd that all come from? But that was way worse.
There is
than
moisture
normal.
in your tanks
Correct.
after a season.
But yeah, blowing into it a lot will get more moisture, and it's not good. Then somebody else will come in and blow after it. Again,
So anyway, like if you see
pneumatic
something on our like our robot, I don't know, last year we had systems that we wanted them to come up at a certain rate, not just like slam up, but come up under control. We would use flow control to do that.
Right.
So you could adjust it, get the two sides to be the same.
And
same thing on our 2012 robot. We had the part that would come out on that, so it wouldn't just like slam down.
And it's important to understand that those control speed, not force. So the size of the pneumatic cylinder is still going to
Yes.
control the amount of force it has. It's still going to control how much pressure it can put out, right? But that just controls speed.
And this one is an inline version, which is kind of nice because then we can we don't have to switch out fittings on a pneumatic. We can just like cut the cord and try it out and see.
Yeah, and then
what the tubing.
so and if you deregulate, if you have the regulator set to a lower pressure, a lot of times people will do that to try to make it go slower, but it's only going slower because it has less force that it's pushing with. The flow control is the proper way to make a pneumatic go slower.
Yeah.
And it does save you from breaking parts. We wrote 2 pickup mechanisms to students realize.
Yeah, I mean pneumatics, if you're running at 60 psi and they're unrestricted, they can really move quickly, and so anything like that. Probably the only place where we don't have flow control on the shifters.
We don't have. We have it on the down of the up of the intake, I think. And I think that's the only place. The shooter definitely doesn't because it's designed to fly.
Right.
And then the shifters don't either because who cares?
So, I have this system set up. I've got some other electronics here that would go with it, but
You want a battery?
we don't use the same electronics. If I had a battery, we could power it up and see. I know it's going to leak because I didn't have a wrench for everything. Oh wait, we've got power back here.
You have the right.
Oh, yes. That works too.
Well, we did that on the field one year when it was still.
Yeah.
We had big leaks and they would go out there waiting for backup.
So.
Okay, so that's the proper polarity. I definitely have a leak.
Yeah, we can all hear it.
You can all hear it.
You can run a compressor backwards.
Yeah. It's not, but it's not backwards.
Well, no, you can run a compressor backwards.
That's not-
It's not good for us, but you can. Some
It's much better.
Well,
I may have pushed it in a little farther. So I'm watching my high pressure side. I'm at 60 right now, or 50. I've gotten to almost to 60. Whoops.
Well, you may have overloaded. Those things have a bit of a safety into the.
Okay, well, it's good enough. I'll just adjust.
Well, yeah, it'll cool down.
I'll just run the pressure down here to like 30 or something. So I'm going to adjust my pressure.
Right after this.
There we go. So I'm taking my low pressure, so it's going to operate at 40, and I've got like 52 on the high pressure side. One thing is the solenoid valves, they have to have a certain minimum pressure in order to operate too. So I don't know what the value is. It's like 20 or something like that. It's pretty low. Okay, so now I can hook this up to power to a battery and move it back and forth. Hey Alan, were you going to give me a battery?
Can't you manipulate the solar?
I can. Just hand me that battery. I was going to show that as what we do. So on the robot. Yep. All right. So now if I actuate this correctly.
Are you doing the dangerous thing?
Yeah, I am.
Yeah, do not show your students.
Ooh, yeah, don't do that.
Please.
There we go.
Yeah, so you can do it that way. There's other ways to.
So now the right way to do it, I just wanted to show them the thing actuating, is there's a button on here, and so you can press the button, and that lets it actuate the cylinder.
Or a pencil, whatever you want to use. And if you do need to test actual like wiring, most of what we do for prototyping is we grab an old robot and actually have it plugged in and run a driver station and everything. So we have an e-stop. Storing this is not something anyone wants to do. We'll talk about this when we talk about batteries, but one of the, probably the scariest moment I've ever had in FRC was 2 of these were unconnected, backed up against each other, crossed 2 batteries together, 18 feet-ish of blue lightning in the air. It's pretty horrifying. Don't do that. Shorting 2 batteries across each other is a very, very bad idea.
And now now I'm done, so I'm gonna dump my pressure.
Did anybody have problems with the relay for the compressor relay? We went through, I don't know, 4 or 5 of them, and they failed. That or the PWM cables connect them, that we had a hard time also getting.
I'm not convinced that they failed. We had problems. I'm not convinced they failed.
Correct. There's the relay side of like the sidecar and things was one of the places that a lot of people ended up having problems over at different times. We had ghosts in our relays as well at different points where it wasn't firing, which obviously should have been, and there was no reason it shouldn't. It works on somebody else's system, doesn't work on ours. The signals are exactly right when you multimeter them, and it's still not working, and all sorts of things like that.
So you're
Hopefully
talking
the new
about
one.
this wasn't working?
Yeah. It's likely that goes away for this compressor now.
Yeah, this disappears, so.
Yeah, that part of the system wasn't working. It wasn't clear exactly what wasn't working.
Right. Yeah, there's always times where there's tricky troubleshooting stuff, and a lot of that you can't really diagnose without having the robot in front of you and a multimeter in some way to figure out exactly what's happening. And a lot of times the code of what's actually being driven to it and everything else.
The real maddening part, Alan, was we pull it out of the robot, we mounted the compressor and relay on a little piece of plywood that made it easy to get out. We'd pull it out, it worked fine in our hands, but it wouldn't work nearly as well in the robot.
No, it's unlocked. The handle just doesn't.
Adam, can you actually go through your slides so we can see what's coming up? Because I realize it has everything,
Somewhat. I mean, this is.
Do you want us to, sometimes we can look at it?
Yeah, these are all online. I'll put up the link at some point on the Spectrum website.
There's also one of the teams, I can't recall the number, but they have a really great pneumatic section.
Yeah, we'll talk 358.
Yeah.
But we'll get we'll go over 358 at a different time as well. That'll be probably part of when we go over history and stuff too.
If you want to see a pneumatics PowerPoint, you should just look at 358.
Yes,
There's also a couple other.
Yeah, this was done very, very quickly to give the most basic of intros to kids. But again, pressure to force, that's the main idea. Really useful if you want to do simple control stuff without complex control systems. So having a motor move something to a certain point is a lot harder than having a pneumatic cylinder do it. Pneumatic cylinder does it in about no work at all, no thought, nothing. You can take something from here and put it here very, very fast. Doing a motor to do it, a lot more work. And a lot less consistent than other issues. Again, storage tanks, the more the better for the most part. You don't want to be running out of air. Air goes in one side, goes out, goes in the other, to come back in.
Question?
Yes.
Yeah, I have, so for this, like double acting pneumatic cylinder and the spring, price-wise, are there any difference?
It depends.
There's not that much of a difference.
Okay.
It's most of the time it's not that big of a deal. A lot of that decision is most of the time, like the reason we did it was an air decision. We knew that it doubled the amount of times we could shift using the same volume of air because we were only pushing down and not having to pull up.
And also you mentioned, using the air numeric versus using the motor to control it.
Mm-hmm.
So space-wise, the weight-wise, you said the control speed and everything is better.
We didn't go over the general rule. So the general rule for pneumatics on a system is once you have a couple different things that you think you can use pneumatics for, it's normally better because there's a high investment cost for pneumatics. You have to add all the storage tanks, the regulators, all of that kind of thing. Compressor possibly. But the next additional cylinder is normally lighter and easier to install than a whole nother motor system. So if you already have 3 pneumatic systems on your robot, adding a 4th is very, very easy. You just add the solenoid and you just add the actual cylinder. Adding a whole nother motor system, you're adding basically the entire thing over again, the speed controller, the motor, all of that down the line, some way to control it, sensors, all that kind of stuff.
The thing about a cylinder is it's here or it's here. If you have something that only needs to be in 2 positions, pneumatics is just a natural. Running a motor to here and stopping it at the same place every single time, and running it to here and stopping it at the same place every single time, not as easy.
And more importantly, it allows you to constantly provide force, where the motors will basically burn up if they're not moving and they're constantly providing force. So you can run a pneumatic into a wall, it'll be applying 60 psi of whatever diameter cylinder is forever. Like it'll always be doing that. And then if you try to do a motor to that and apply the same amount of force, the motor is no longer moving, it's stalling and applying that force, and it will eventually burn up. And consume a lot of power to the battery and do a bunch of other things. So if you need something to stay there and forcefully stay there, pneumatics work very well for that. There's other ways to do it. There's mechanical ways to do it where you can do cam locking things and design really cool linkages and stuff. There are really, really successful teams that don't use pneumatics. But the more successful younger teams do use pneumatics because they can do things without control systems and without complicated
But
hardware
worrying
things.
about the total energy you can store, pneumatics is the least efficient way of consuming that energy. If you have problems with storage.
But you pre-store the pneumatics off of different batteries, so
You can, yeah.
right. So most of your air is pre-done, so you're adding energy to the system by being able to store it
If
pre-loaded.
you're consuming so much that you gotta consume battery power to run a compressor.
Potentially.
Right, that would be the trade-off, but like in our case, we
This
didn't.
is off board, so you can.
But the battery stuff you can play with a little bit. With the transducer, you can do things to make it
I
not
saw
be as bad.
a
and
graph
things like that.
like this for talking about pneumatics, where pneumatics have this really high initial cost in weight and money, and then it just plateaus, or not plateaus, but it's not nearly as steep as it is. Motors are pretty much linear because double the motors, double the cost, double the weight. But every time you add another cylinder, you've already got the compressor and storage and the pipe, the tubing, and like in our case, we already have the manifold. We mount a six port or a six solenoid manifold, and then we cap the ones we're not using. And so if we need to add one, we just remove a cap and put another one in there. That way we don't have to redo everything.
Yeah, and pneumatics can be expensive, like the cylinders themselves. Every year, BIMBA donates 3 cylinders per team, and you get to order whatever ones you want. So you just go on a little BIMBA form, fill it out. A lot of teams, for some not really unknown reason, because they look cool, will order the like 24-inch stroke, 2-inch bore monstrosities.
We have 4 of those.
Yeah, everybody. Most teams have them. Nobody puts them on robots. Like they got on a couple climbers that didn't work.
2008.
Right. 2008.
Yeah, we had a.
Oh, that's interesting. Whatever. The amount of air it takes to put a 24-inch stroke cylinder, but yeah, you can do it. Don't do it. It's much better to get 1.5-inch bore, 8-inch cylinders, or 1.25-inch bore, whatever, smaller ones that you'll actually use, right?
Okay,
Find
our
some force.
strategy is we get from Bimbo what we can't get from Granger. If I can get it at Granger, I buy it at Granger, and I get a weird thing from Bimbo that I'm guessing gonna need sometime in the future.
Right, it just depends on if you're ever going to need it. So, like, we don't think we'll ever put, like, I can't imagine putting a 2-inch bore cylinder on my robot unless we're doing something crazy. And it's not going to be in 24-inch stroke.
Well, not
So-
24
so-
They give you the free ones.
Yeah.
But don't count on the free ones, because if you order them, like you say, are we gonna need pneumatic cylinders? And then after a couple of weeks, you go, hey, let's order those cylinders. We need this one, this one, and this one. It could be 2 weeks or longer until you get it.
Right. So
These free ones take a
the
long
free
time.
ones we almost always use. We wait to do the order and we use those as spares. So we'll buy the real ones, then we'll know what we're actually going to use, and the free order will be the ones that we go on a practice spot or go as spares for our competition robot in case we break one.
The free ones from at any point during the season?
Yeah, up until championship ends.
Right.
It's the same. The order form or whatever is open. Like all the
You
virtual
get a
kit parts for the
code.
most part are through.
Oh, you
it's a
don't need
link
a code,
into-
just put your team number.
Yeah, you just like put your team
Yeah.
number. Oh yeah, I know.
Yeah.
3 any size, and the Bimbo ones are also nice because you get. There's a little checkbox for magnet, which allows you to actually sense whether it's at full stroke or not. So if something interrupts it and it doesn't get all the way to full stroke, you can actually tie that back into the control system, and it has a little magnet on the rod, and it'll check it. I've never actually used it, but they normally add about $15 to each cylinder, but the Bimbo ones are free, so check
Automation
in.
direct.
Right. Yeah.
One thing on the air thing is you don't break them as often as a motor. If you have an arm sticking out, you hit a wall. So we used a 2-inch bore cylinder as a spring. Set it at about 25 psi. It would deploy the arm out of the perimeter for starting purposes, and we used the motor for tilting, freewheeling motor, but we used the pneumatic cylinder as a counterbalance / spring. And when designed so you hit the wall, it would move,
Yep.
and then come back to its position. You put a gearbox in the same place that has to support that, that doesn't, you can
Correct.
break gearboxes really
Yeah,
easy.
so that's a lot of the stuff that sticks out should definitely, it's better to be pneumatic. So, I don't know, when did you strip gears from impact on your arms? Or-
Usually when we strip gears, it's because we shoot and it would hit the arm.
Okay, so that's not as the same, but it would be the similar
It'd be-
thing. But our
it's
intakes when
probably
they come
happened.
down are pneumatic, so that if we run into a wall, like we can run straight smack dab into the driver's station, and we don't break our intake arms because the pneumatics just give. Like I can lift them up by hand; it doesn't really matter. When they're up and locked, I can pull them down to get the ball out, whatever we need to do. Because as long as once you break that little bit of force they have, and we have a pretty large lever arm, so the little tiny 1.5 inch stroke pneumatics are mounted really, really low. So physics-wise, we have a huge lever arm out of that point. So it's fine with the ball, but any robot, anything like that, we can't really damage another robot with those because they'll just fold. They take very little force to push back up.
2 years ago, those friendly Texas robots bent all our deployment arms that had gears on them.
Where was this?
We were here in Houston.
Here at Houston.
At Lone
Lone Star.
We're so gentle.
You guys were very friendly.
It wasn't
No, you guys, I'm saying the Texas robots hugged our robot a lot. They were very friendly.
No, we were very, yeah.
2 years ago.
What was I gonna say? So when we talk about only being able to go to 2 positions, there's creative ways to make them go to 3. You can have something that turns and locks in front of it so it can't stroke out as far. If you put 2 of them together, you can then get 4 different positions depending on lengths. Teams have used that successfully. There's lots of different creative things to do. Again, Chief Delphi is a great place to go through look. One of the things I also try to instill in my students all the time is the more robots you look at, the more robots you understand how they work, the better you'll be at designing and building robots, because most of the time I don't come up with something magically out of the air that goes on a robot. It's, oh, this robot was used on 2012 Killer Bees robot, they did this, now it goes here. Like, it's not, oh wow, this is the exact thing I need and I just magically came up with it. That almost never happens. And if it does happen, it normally breaks pretty quickly.
Do you guys have like a recommended like stuff we should try to buy ahead? Do you have like a list
Like
to
if
help
you're
us?
at pneumatics.
Or just parts that we should be like trying to buy ahead of time, you know what I'm saying? Like, recommend, 'cause we're not gonna know what we need to buy.
Yes and no.
We don't know.
Right.
We don't know for sure what anybody needs to buy right now.
It's hard to know everything, but we can talk more offsite. And a lot of that is what resources you have, what you don't. We can go through all of that. And so when I came on Spectrum, it had been around for a year, but they didn't really have much of anything. So I was basically starting from scratch, except the students knew that they wanted to be better. They had a decent year, but they weren't great. So that was really good, actually. It was fantastic because they knew what they didn't want to do and to get more. So they put in a lot of time to get better. But we basically had to rebuy everything for the most part. So I can go through, I have a lot of that stuff.
But I'm sure, I mean, if you have to have the circuit every year, like we're just talking about,
Right,
we
but-
should be buying that stuff.
Yes and no.
Largely free.
So
Okay.
if you do it right, and get stuff outfitted for your robot with what you can get from First Choice, with what other teams are going to be able to give you and things, because
Do you guys know what
they
First
stockpile them.
Choice is?
I've heard, yeah.
Right, and we'll go through some of that
Couponing.
as well. Right.
Yeah,
kind of.
I wanted to make sure that when he's mentioned.
No, I'm aware of
It's
that.
part of the virtual kit of parts.
Yeah.
Finding out when it opens and being there early and making lists and talking to somebody else who's done it before, that's probably one of the bigger ones.
It sounded like this.
Yeah, I can definitely help. I love First
Like
Choice.
Black
I will be
Friday.
sitting at a computer.
Yeah, and I do
When
a
First
bunch of
Choice starts.
spreadsheets before First Choice, figuring out what I want and how I can do it with all the credits. So
Yeah.
it's definitely
You're probably the guy keeping me from getting on faster.
But you're gonna have to,
Could
but
be.
you still don't have what the build is, this is done before that Saturday.
First Choice.
Kickoff, right?
First Choice is all done in November.
November, not December.
And after kickoff.
No, there's
Oh,
two.
and there's one after
Yeah,
kickoff.
They
now.
gave us
That's true.
150 points
There's
before
one after kickoff
kickoff
now.
and 450 after, but
Okay.
the parts list did not change.
Correct. So you had to know, and on the 150, you had to know what you really wanted and what was going to sell fast to get that first, and then what you wanted on the 450 and get
We're not
that
gonna know
later.
that if we don't have experience doing that.
That's one of the ones where you ask somebody else.
Okay.
Because we can definitely tell you what's going to
Okay,
go.
be
We can
aware.
put an order list for you, that kind of
If
thing.
you do not get a confirmation email fairly soon after you submitted your order might not have taken.
Right, and that is,
We
again,
lost stuff this year because
all
of
of that system will be overhauled again this year because it wasn't perfect. It was really bad 2 years ago. They made it infinitely better this year, and they're going to step it up again. They're
And it was pre-tested.
yes,
And it was
new
abysmal.
system. It was this year. I didn't have a problem this year at all. Other people did. I didn't have a problem 2 years ago either. But
Yeah.
it really depends on how you use it and how fast you're willing to click buttons and make sure everything.
Yeah, I think so.
Yeah, it did crash me with the service.
it immediately crashed.
Was it?
First open.
Oh yeah, that's true. But then it opened again.
Right.
Well, that was actually good because I couldn't actually be there when it opened this time. I was running we were running a Vex tournament. I had to log onto my phone. It was terrible. Okay, so we can be done with pneumatics because we spent a very long time on pneumatics. What?
It out too, so if people wanted to snap a picture of a layout.
Yeah, absolutely. And
it would be something. I'm just going to leave it setting here, so.
And we'll get that robot actually running and firing pneumatics at some point as well. I don't know if we'll do that tonight or tomorrow. Okay, so let's do something non-technical next. What would people?
First has a pneumatics manual published about every year, if not every year.
Yes.
Go to the first page, look up in technical resources somewhere. They've got a pneumatics manual, and it's really well written. Talks about every single part, got a nice big picture, explains what the part does, where it has to be plumbed. It is a really nice document.
Yeah, you can go through the pneumatics manual and get it all out.
It's
I mean,
really nice.
the rules themselves got updated this year to where the picture actually makes a lot more sense, and you can get halfway there just by looking at the rule book. It has a layout and the picture in it now, so they did a much better job this year. It used to be pretty confusing.
Basically everything that I item by item that I went through.
Right.
Like you said, there's the heading, there's a picture, there's a description of the part and what it does.
Right.
Very well.
And
well,
now
schematics.
probably the harder part of this whole thing was the wiring with the new module that they're introducing. Everything's labeled. You plug a bunch of stuff in, and it should just work.
Okay, so I don't have to guess.
It should be fine. No one's used that yet. The beta stuff is all coming out to its beta teams soon. But
I saw that.
in theory, everything should be right.
Yeah, it's gonna be great.
Yeah, it's gonna be awesome.
Awesome.
And Greg is here, by the way. Greg walked in. Greg McCaskill's from NI. Yay. He has the new control system over there. We'll be talking about a lot of that tomorrow. We're gonna do a little bit about what the changes are and kind of what's going to happen today. But a lot of the actual seeing it and stuff will be tomorrow morning.
Oh, I see water over there.
Water game.
No.
If people want water, yeah, there's water. We can also, I can get snacks if I can get to the back of the lab. All of our stuff's packed in there, but we have a bunch of snacks left over from when we sold concessions at TRI.
What does NI stand for?
NI is National Instruments. They are the people who make this current C-Rio and are making the Robo Rio, and big supporters of FIRST, do lots of great things. We like them a lot. Thank you, NI.
I'm like, oh, okay. Thank you.
Yes.
5-minute pause. Non-technical, 5-minute break.
5-minute break. That is a good idea, and then we will do something. But
And tell
before
me where the restrooms are again.
before we break, what do we want to do afterwards that is not technical? So we can do outreach stuff. We can do brand stuff.
Yes, grants, fundraising.
Grants.
We want to do finance stuff today, or do we want to do it?
I actually want to know, for this competition that we are involved in, how many awards category there are?
We'll do awards along
Yeah.
a different one. So that's another option. So
Read the manual.
What if we
Scott, do you want to do money right now, or do we want to do
With the entire team as we did.
award outreach stuff?
Oh, beautiful. Okay.
I'm game for anything.
Also recruiting.
Any other opinions on what happens? Votes?
This was kind of under the technical category, so maybe not.
Okay.
But tomorrow or sometime maybe it would be beneficial for me to hear from the different teams, like what they thought were important tools that they got in their shop that really allowed them, or I don't know, give them greater flexibility.
Yeah, we can talk about tools. That's a good one for tomorrow. There'll be a few more teams here too.
Yeah, like arbor presses or binder saws or bandsaws. What did people get that?
Yeah, and that goes into what we'll buy as rookie teams and stuff too. That we can definitely do.
I'd love to hear Rip talk about day zero. Run me through your first 24, 48 hours.
Build season.
Okay.
Just kind of general what you think should be happening by a certain time, maybe. Well, I'm kind of guessing.
You run that.
There's a file in here of all the suppliers I've found over the
It's
years.
different depending on.
I'll show you where it is. I think we should share it with everyone.
Is it okay to call you Rip? I know all your kids do, and that's what I've heard you refer to over the last year.
Do what?
Is it okay to refer to you as Rip or Mr. Rip?
Mr. Rip.
Mr. Rip.
They call me. Sorry.
But yeah, you can call him Rip.
Call me Rip.
I don't think that. Yeah, that was a misunderstanding slightly.
They do.
But
They do eventually.
But yes, you
when
can.
they're seniors and they're leaders, they think they're big shots. They call me Rip.
Right.
Okay.
Or when they graduated.
And then.
Or once they call me Rip.
Okay, so did we come to a consensus on what our plan was for the after break?
I think the first 24 or 48 hours after kickoff is a good topic.
Kickoff. Okay, so I want to do some engineering design process stuff anyway. So briefly, because
Well, that would go along with that.
right, and we do that entirely again. So people who want to come to Houston again in December, I had a date. I don't remember what it is. We do mock kickoff, which is basically an entire day of me just doing engineering design process with a bunch of people. So we'll talk about that later. Okay, so let's take a break. Bathrooms are out that way. There's water. If people want snacks, I can figure out where they are. They're in the back lab somewhere. If you can find food in the back lab, feel free to eat it.
Just getting to it.
Yeah, Scott, if you find a honey bun, I would like one. There's a seat. There's an easier stash directly to the left. There's like a Sprite box. Yeah, that stash is what we took to reboot. There's a bigger stash in the back. It's hard to get to.
Okay, go to Robotics 2014. Go to Mentors.
Hey, I couldn't get onto the Wi-Fi for some reason.
You'll just see a bunch of my logins. Get up to the page and I'll log in. I hate they tell me I'm not supposed to do it, then their system doesn't work.
Oh, that's strange because they said that I already have a username or something there.
That's even more
Okay. So here's what I did.
Big down there.
I don't.
who's our Anadarko mentor. This is the only time during the year we see her. So she goes down to U of H Clear Lake, picks her flowers, and Mr. Merrick and all those people to say their things that they say, waiting for that moment when they're going to reveal what the problem is. Sometimes we take care of some of the business sorts of things before they come out with that what the problem is. But eventually they'll do the reveal and we'll get to see what the challenge is. And the moment they do the challenge, the moment they release it, they also give you the password for the manual. So we've already downloaded the manual at that time. And the moment they flash the password, then usually it's me. I'll enter it on my computer and I will print out a copy of I think it's 4 sections, like 6, 7, 8, and 9 are the sections that deal with like the field, the game, the robot, and
tournament.
So, Scotty, everything. So then we go to lunch because I want to get the copies made and stuff. And they go off at lunch. It's totally disorganized, the lunch break, because they go off in different groups and everything. We tell the leadership that we'd really like them to kind of make sure that we don't have new people go off by themselves. But they just go off and it gives them a chance to kind of talk about things a little bit and stuff. They don't know the specifics of the rules yet. I don't want them to know the specifics of the rules yet because they'll already be thinking about, well, you can't do that because it would violate this rule. We're not at that point yet. We don't want to know. So they come back from lunch and we'll start, everybody will have a copy of the rules at their table, and then they'll take time to read through the rules. And we just have each one of the tables spend time reading the rules, and talk about what the rules are like. We don't go through it like the rules are up on the overhead and talk about it page by page or anything like that. And then we'll start talking about, pass out a bunch of Post-it notes and start talking about what do we think the robots should be able to do. And before that, we talk about the game and how we think it's going to be played as far as points go. Because, like this year's game, one of the things right away that I was thinking about, and other people were thinking about too, was how in the world are the referees going to keep track of all the stuff that's going on in the field? Was a big concern. Just how hard that would, I mean, not even strategy-wise for us, just thinking about from a referee's perspective how that was going to be. But then looking at, were you going to the catch and the truss and how many assists and did we see robots, what was going to be the role of the defensive robot? And we always go down, after we've read the rules, we go down to what we call the commons area, it's cafeteria, and we lay out a field. And we had something representing a truss there and everything. And then we kind of play the game, 3-on-3 robots. And we talk about the role of some of the robots. So we had a robot assigned to be the goalie on one end of the field, and we had 2 robots that were assigned kind of to play together, and then we wanted another robot. We tried to come up with what different roles they might play during the match. One thing we found out was that a defensive robot that was playing goalie was worthless. So. So that was something we nixed right away. It was something we didn't want to do.
This is what humans look like playing a robot game.
I was hoping you were going to pull this up from the Crossroads Regional.
No, I'll pull stuff from our gym.
Well, no, the Crossroads Regional, the Spirit, or Team Spirit Award.
Yeah.
Our guys have to play like crab balls. So they're not on their hands and knees, they're on their backs.
Well, okay, I see what you're saying. It depends on what they're able to do, right? So every one of those guys were to find a role of what the robots are allowed to do, how they work. They're playing the different human player games. At this point, we had actually built a goal, I think, that weekend. not as good as some of the robots. Still going. Yeah, we were trying to clock cycle time, that kind of stuff.
We talk about, like, you'd watch them, like the kids would be playing a game a certain way, and we'd say, you know, you can't do that, or then I'd be flagging them because one of the kids would come over, and on their way to play defense, they sort of knocked the other ball away, and if I saw, you know, if I thought they were doing, that they had purposefully deflected that ball, that, you know, I flagged them and stuff, so they kind of got used to what some of the penalties were and stuff. And so we do that, and then we go back upstairs, and now we start talking about the robot and what it needs to do, and they take their Post-it notes and they just start writing things down on the Post-it notes, basically. And it's really free form because I don't say, you know, they have Post-its. They can write down like questions they have. They can put down like strategies they have. They can put down things they think that should be on the robot, what the robot should be able to do. And then once they've done that for a while and it looks like they've kind of exhausted it, then we'll take the big whiteboard and we'll just start pulling Post-it notes and go to each one of the tables. There'll be like 8 or 10 tables with 5 kids at each one, and each one of those tables will, you know, they'll give me your best Post-it, you know, the one they think's best, and we put it up there, and then I'll go to the next table, you know. And so they're trying to, not exactly outdo each other, but they're trying to come up with what they think is a really good idea. And I'm kind of sorting them out on the board as we do it. So there are a lot of times there is like a strategy area, a lot of times there's a drive base area. Then there'll be like different types of manipulators underneath that. What do we think the robot's, you know, how's it going to shoot the ball or whatever? What do we think the robot ought to be able to do? And that's pretty much ends day one for us.
Yeah. So,
what is the role of robot in 3 days for you guys?
We didn't really, I mean, I know I had kids looking at it, but I knew a lot of people that were doing it.
Yeah.
So I kind of watched as oh, this is cool, I get to see Jesse.
And I was doing one, so.
Oh, okay.
So I'll talk about how
right.
ours worked. Yeah, we did one at Rice, and so my kickoff this year started crazy early. Get here, get the bus, load kids, go down to Clear Lake with everybody, help do kit distribution. We're normally back here right about lunchtime. By that point, the kids who are doing kit distribution aren't doing this, but everybody else, they have their computers or iPads or whatever, and they've already downloaded the encrypted manual. All of them are reading it. By the time we got back here, the kids who go down to kickoff should have already read most of the manual, at least once. We've discussed some stuff on the bus ride back and things like that. But then when we get here, we meet quite a few of the parents. We bring back as many alumni as we can. That's the big social event of like the entire year, is that like first 3 to 4 hours from like noon or like 1 to whatever. We try to bring back more people, so we get all the ideas we can from everybody we can really early. They normally are there till about 5 or 6. The process is similar to what Scott was talking about. We don't do the sticky note thing, but we do as a group go through and read, at least highlight the major rules. So by the time we've actually come back on the bus, we know what the major sticking points are most of the time. But we go back over again because half the time somebody will read something wrong, announce it on the bus, and then everyone thinks it's that way. Then we get back and realize it wasn't actually that way. So we will go over as a group, kind of line by line, dissecting and making sure everybody has the right interpretation in their head before we start designing anything. That Saturday lately has been at least before the start of school most of the time. So me and the crazy person I am realize that parents don't care if their kids are home really because school hasn't started. So we work crazy hard those first roughly 3 days because a lot of times, at least Drake will have that Monday off.
Yeah.
St. Agnes sometimes doesn't, but a lot of people do. So we'll do crazy hours. Like I'll normally, I think kickoff day for me was got here at like 6:30 and I left here at midnight-ish. And that's like probably when the last student left too. And then as soon as that happened, I went to Rice and worked on the robot in 3 days build for 4 or 5 hours, and then went home, slept for 3-ish, and came back here on Sunday to finish doing prototyping stuff. That first 3 days or so is where we're allowed to play with kind of crazy ideas and off the wall things and build whatever the kids want to build. And not necessarily have a lot of direction. Like they'll spur off different groups. We built a little bit of everything. I don't know if all of that is in there. One of the worst things, where is it? We'll prototype random things that other teams won't prototype. Do we have it? This is I hate this video. This video has 10,000 views. I don't know why. It is awful. This is a puncher somebody made. It does not work at all. The whole thing, like
10,000 views.
I don't know why. I'm assuming other teams are just making fun of us. I don't know what they're doing. 10,000 views. You can't possibly get 10,000 views. That's all it does. It's terrible. It's the worst thing I think we've ever made.
Hey, you have to prototype and try out.
Where am I at? That's not the video I wanted at all. Stop it. I want this one. So, no one thinks to make this video. It's 6 seconds long, but it has nearly 2,000 views of a ball being pushed into a logo cutout. Surprisingly linked by a bunch of other people. So we'll do a bunch of random things like that to make sure systems we think are going to be really easy actually work. A lot of it isn't even just for our need. We'll make the video, post it, and people who don't have a ball yet or don't have access to one be like, oh, that does work, and they'll comment and like or whatever. So a lot of what we do early on is how can we do the simple stuff that we'll eventually be able to tell other teams how to do, and they'll be able to do it even if we don't plan to use it in our design stuff. So we'll have some students go off and build, like, oh, this simple robot could be cool. We may not build it. Go test it and see if it works, and when we go to a build day with somebody and they don't have a robot design, we can pitch this one to them. I think somebody can build it, even if they have very limited resources. So we'll have a lot of different groups. Some of the stuff has nothing to do with we'll ever even see our robot, and we know it. What else happens that first weekend? We try to go through some amount of structure at some point on the actual engineering design process of how do we want to play the game, and doing some of the math behind it. So after we've kind of done some of the rules, we'll do the scoring analysis stuff that Scott talked about. So we'll add up, figure out, what do we think max score is? Like, what is highest score is going to be what throughout the season? At Champs, IRI, kind of scaling it to where we get our numbers right? Like, how fast do we have to be at something? Part of the reason that human player game was we were clocking what we think cycle times could be with robots, right? We were way faster, I think, than ever, because most of the time, if you were getting 4 to 5 in a match, you were having a good match.
Yeah.
But if you got 2 in a match at some regionals, you were doing really well. So you're wrong a lot of the time. Most of the time, you're wrong that first weekend.
Yeah, because that's like if you don't go to a week 1 regional, because the regionals are spread out over 6 weeks basically. So if you don't go to a week 1 regional, you watch it and you see how the game is getting played.
And you can even watch the week 0s, which there's a few, not official, not necessarily, there's an official week 0, but there's a couple other ones that are on legit fields that are very good robots that are near complete and everything. They happen before build season ends, and we even watch those to get an idea. To answer your robot in 3 days question, so like I said, I was part of one this year, so we were working on a robot. It came out okay. Quite a few people got inspired from it and built the design, so that was worth it. But the other ones, when we were here, there was almost always some laptop streaming at least one of them somewhere. Most of the time, no one was just specifically watching it, but during breaks and things, someone would go check on what was happening. We'd watch the little updates and stuff. We don't see a reason if they're going to show a design, it's just more basically mentor help, right? We have people who've been doing this for years. The Robot in 3 Days, for people who don't quite know, there's one out in Florida. Andy Mark did one. Team Boom done up in, actually the people at iRobot with Dr. Joe Johnson, who was a former FRC mentor and just started again recently. And then Vex did 2 this year as well. So and 1 at Rice. So there were 6 robot that were built in 72 hours, complete from scratch, basically.
Oh, that's right. Vex had 2 going.
Yeah, Copioli and JVN. So there were a ton of robots built in 3 days. This is the first year there was ever a ton. The year before there was 1. It really didn't change much because, frankly, design wasn't great. There weren't too many there weren't too many teams that built that robot. This year that was entirely different. There were many, many teams who built Robot in 3 Days robots. This robot was inspired off the Boom Done one. Took it and iterated every system to where now nothing is like it. But it was the original idea, and kind of there's a collector, the launcher launches backwards, was from Boom Done.
I don't know if our robot reflects any of the Robot in 3 Days.
You had a choo-choo at one point, right?
We did have a choo-choo.
That's the only thing that was really Robot in 3 Days. Right. Was Aaron Hill published Choo-choo mechanism, which is double
Aaron Hill
acting
works
cam.
at Innovation First, and he was with Winnovation.
And he built it on a Lego robot in 7th grade and says he's never seen it anywhere else before. So yeah, he may actually have been the inventor of that one. We're not sure yet. He doesn't think he is. He assumes somebody made it in history and just we don't have a source for it. But
I think it's Aaron Hill.
yeah, but
He's a celebrity.
I have a trading card that says it's Aaron Hill, so it must be. But yeah, the Robot 3 days are very, very useful. Talking to other teams too. At that point in the season, like once you've been in a while, you end up with lots of Facebook friends and stuff who are talking about it and doing, not necessarily posting stuff, but you're having different discussions. There's normally the Robot 3 days have different, like they'll have talk show elements of it where they're interviewing people and talking about what they like about the robot, what they don't. Stealing little features and things from those types of robots are another way to say something that you don't have to come up with, right? Anything that you can take a design from somewhere else and implement it and know it works saves you a lot of work.
Our team works with, not as much, we didn't do it as much this year, but the previous 2 years we worked a lot with 1323 in California and 2415 in Atlanta, 125
last year. Yeah, last year all of you were kind of.
Yeah, all our robots look pretty similar, and so we would share a lot of ideas. So we had a lot of trouble getting our magazine to work, and then we ended up using something very similar to what kind of a compression setup that 1323 had, I think. And I don't think they ended up using that. I think they ended up doing something different, but we made it work for us.
So yeah, you'll see a lot of that. There's in-season teaching and things happen pretty regularly.
So then after that initial, like we have all those ideas, then and he already mentioned the prototyping. So we move into doing the prototyping. And so for the prototyping, we have a lot of, we tried to use a lot of like fancy stuff like 80-20 and things like that. It turns out it's so much easier to prototype just using like plywood and stuff, because you can just screw it together or fasten something here and it's done. You've got it put together. So
we have a bunch of spare like scrap that we had from one robot that have a bunch of holes already spaced through them that we just
we have the same thing. We have a couple of tubs full of spare parts that backup parts from old robots, and if they look like they'll be useful for prototyping, they just get tossed in that container. Otherwise, they get taken to the recycle place. And then we try to do a bunch of prototyping. So I know the kids, we prototyped. We thought catching was going to be more important, and so we had a lot of catching prototypes go on this past year. So we had a version of the robot. I don't know if the picture of our robot was up there, and so at one time, the way this robot was going to be, so this seemed pretty set, though originally this was all going to be aluminum, this whole frame, and it turned out it was like crazy heavy doing it that way. And but so that was going to be aluminum, and then here on the side was also going to be aluminum originally, and it was going to flex out. And then each one of these, I called them leaves. It looked like a flower. My code name for the robot at that time was Venus, because it looked kind of like a Venus flytrap, and it would open up. The idea was somebody be able to shoot into it, and then the robot could just like close in on it. And I kept like struggling with how can we get all these pieces to fit in the frame, and the ball's got to fit in there, and all this sort of stuff. And I tried several different ideas. The kids worked on some ideas where they had them spread out and everything. We were looking at it, and we found out some things about the way the ball's going to bounce in there and so forth. And then we ended up, like, at week 1, nobody was catching the ball. It was not a part of the game, basically. So, fine, let's leave it. And we also kind of figured out we might be able to do catching with just this apparatus if we lined up correctly. Because when you're on the field, you're looking from one end of the field down to the other. And so if I'm trying to shoot the ball into your robot, then that's a little easier to line up than if the robots were shooting from sideways. That'd be almost impossible. But we also were coding, one of the things the kids were working on was a program that would allow the robot to follow the ball while it was in the air. So it would take like the first couple of frames and predict where the ball was going to be, and then it would take the robot to that position. And they ended up not doing that because part of it was because we couldn't find a place for the camera to go for a long time that would work well, and catching turned out not to be a part of the game. So we just scrapped it completely.
How do you guys balance, you know, like focusing on ideas versus people wanting to kind of start designing things, right? Because like down in Dickinson, we would usually have a, you know, I don't want to see a design or a prototype on that first day. Just talk about ideas and strategy. But I felt like we always went too far that direction. Like if people want to draw something up or whatever, but then you don't want to get focused on that design.
On those post-its or sketches sometimes.
Okay.
The kids, post-its are this size, and they'll draw little sketches, and then sometimes I'll have to come up and actually draw. What do you mean? What did you have in mind? And then so they'll sort of sketch what the geometry would look like.
Do you guys try to limit that, or do you kind of let them run wild if they start trying to design something right after the?
Well, I mean, no one's gonna leave after Saturday, and I don't think anybody's gonna leave and start designing. It's just not the way we work.
Yeah, we have people who will be working on prototype stuff that night, but that's intentional to get stuff done. Like, and I want, like, if they're that interested in the idea, that's fine. But one of the things we talk about at the beginning is it's no one's ideas. All the ideas are the team's, and if we don't decide on yours idea, it's not because we don't like you. And that can happen on occasion. It hasn't happened since I've been here, which has been nice. No one's been like, nah, like, you know, they've been pretty good about it. On occasion, they'll come back and be like, I told you that we should have done that. I'm like, yeah, you're right. Because one of the kids was really on a wheeled shooter, and I was like, oh, that can never work. And then, you know, Cheesy Poofs won the whole thing. But he didn't have the Cheesy Poofs design, though. If he had that, we might have done it. But yeah, it's not a big deal for them to do it if you have the time and the energy, and you can make sure they're not solely focused on only that, right? The goal of any of that initial prototype design stuff should be finding a reason why it doesn't work. Right. Like, that's a lot of what we do is go, this is great, now break it. Why is this going to actually play the game well? What's wrong with it? This seems really awesome. Does it meet, you know, this feature that we talked about that we want to do? So a couple of things. Let me get back into the PowerPoint really fast. I think I have slides.
Now, you know, after you've decided what to do, as we go through what, you know, first how to win the game, we keep breaking people in different groups to rotate ideas around a bit. Then we have the groups do mock-ups with popsicle sticks. And so, well, with 54 students, we have like 8 groups going, or 8 or 9 groups, so we get a whole bunch of popsicle stick mock-ups and mechanisms. And then the team sort of starts discussing now, and then we do that. Otherwise, I won't tell you how many sheets of plywood and 2x2s we went through some years. We try to, before you get to our wood mock-ups, we try to get down to 2 or 4 concepts.
We did that with Connects this year, but students had a hard time trying to understand reducing the scale of every aspect of it.
You're just doing concepts.
Yeah.
And it's so we actually have the other problem. It's harder to get my kids sometimes to go in there and actually build something. They would rather design it or something. So we're very much, if somebody wants to go build it, I'm like, go, have fun, do it.
One other for us that's really important right at build when we start is we have a lot of alumni come in who want to tell them how to do everything, and we're not for that. So the alumni have 2 jobs. They start building our field structure, the play structure, but also really important, a couple of them have to build a 2x3 foot scale field. And so by 2 to 3 hours after kickoff, we have a visual 2x3 foot scale field built out of popsicle sticks. And now it also helps when you're looking, because you take it from the screen, and now it's a 3-dimensional object, and that really helps besides running around, getting concepts. And that's our alumni out over here too.
So specifically about this year's game, I mean, at what point did you guys realize like the over the trust to the human player pass was going to be such an integral part of speeding up the cycles? I mean, did you know that going into week 1?
Into week 1 of the game, like played.
Yeah.
Yes, we knew that about day 3 or 4. I said, why are the human players in the position they are? Oh, it's to shoot to them. The ball should never hit the carpet, and that ball never on carpet was on our list pretty early. We never actually got to play that well, but
it was the same idea. Was we understood that if you get the ball to the human player, then you're going to increase your cycle time.
Right, and I mean, but that's also, I was also harping human player pass back well before I think anybody had actually done it on the field. So like there was a random thing. I was trying to get my kids to do it, and they wouldn't. They're like, oh, it'll never work. I'm like, oh my god, human player pass back's gonna be awesome. And then it finally took off at like champs. But so that's not always. It doesn't always work, even if you think you have a good idea. It doesn't always get implemented.
Something that happened at on the Archimedes field is I'm trying to remember which robot it was, 1980 maybe. They ended up parking at the 1-point goal on it, and one robot shot across the truss, and they did the pass back, and then they tossed it into the third robot, and they just shot it. They were
so mad at myself right now. I can't think of the number.
They lost at 2056. No, they beat 2056. Yeah, they beat 2056. They're Lions.
Yeah, it's the Michigan team who I can't name right now. Is it Bedford?
2468, which is parked right next to the human player station. They just toss the ball in, they fire, and it wins every time. That was a pretty decent strategy.
Right.
Yeah.
As long as no one pushed them out of the way.
So.
Right. Well, that's why I think the team, like I said, 1980 or whatever it was, they were parking up against the 1-point goal, and that was another thing that we saw. Like at the Dallas Regional, our robot was able to shoot on the fly, and we could do a three-goal autonomous, or 3-ball autonomous from the white zone, and then we could shoot that same shot on the fly, like almost as soon as we got underneath the truss, we could shoot that and have it go in. But that's not how the game was being played, and it wasn't as consistent a shot. We saw like the Hawaiian kids, Brett Dallas, and 148, and they were all just basically they drive up to the 1-point goal and lay it in, and that was it. And so we adjusted our shots so that basically we were playing in that same zone. The design of our robot wouldn't allow us to go up against the 1-point goal, but we call that the layup shot, because there was the same thing in 2012. Was you could have robots that could just drive up right up to the fender, yeah, and you drive up to the fender, and then you just lob that ball in right there, and it was a really easy shot because you just plant yourself. That's how we won Alamo. We just did fender shots. Our robot didn't have nearly the capabilities at Alamo that it had later in the season.
let's not bring up Alamo 2012. There's some broken hearts from other people.
Robot normally has a fender type shot, and that's what they do every single match until somebody blocks it, and then you find out they can shoot anywhere in the field.
Well, they didn't always have that. They just got constantly better throughout the season, and no one noticed.
But they used the same tactic back in 2004 or 5. They had essentially a fender, wherever aim I was, they had a fender shot, and at Nationals, they got blocked, moved out to a whole new location, shot all the popper right into the high goal still.
Yeah, no, they got, Chiefs got mad at me because what they did on Einstein to go around like the goalie poles, they had done it in a single match at SVR, and I had like posted the video on Chief of them doing it, and it was like, oh, they know how to get around goalies because we were building a goalie, and they were like, oh, cat's out of the bag now. I'm like, well, you shouldn't have done it in a match.
But they always have more than one. They have a simple one that they do, which is deadly accurate and very quick.
Yeah, figuring out ways to do something extremely repeatable is how you win in first, but it's not easy.
We spend a lot of time on consistency. So we want the robot to be, I personally want the robot to be simple. So I'm on one end of the spectrum, fighting that all the time. And then on the other side is James, who has James Contat as the lead design mentor for our team, and he's sort of like, no, complex is good. So there's this kind of constant back and forth. And so I was kind of happy that our robot ended up being fairly simple this year compared to what it could have been.
So I'm the only mentor, but I just have that conflict in my head where I push really hard for simple, and still I start designing things, and then I design really complicated mechanisms.
I was going to say, there's actually, it's not as much a more complex, less complex, but there's actually a third side to it, which is the complexity of code that runs.
Yeah,
so
I don't even know that part.
Yeah, he prefers the simple robot, super experienced drivers. James Tomthat prefers a complex robot that does all the issues mechanically, so simple code, simple drivers. and usually programming prefers simple code, simple drivers, simple robot, complex code. So it's balancing all three of them that it's more fun.
He is. I all the years I've been involved in robotics, the one secret to being successful is having a robot that the students can practice with, and they get to practice with it, and that is the secret to success.
There's practice,
Yeah. And then if you make the robot simple and reliable, so it doesn't break down all the time. But there is no, I mean, we'd go to competition, and there's people still putting their robots together, and they've never driven their robot. And here we are, and we already know, I mean, we're like practicing little special maneuvers and stuff. So it's an incredible difference. And it's something that we've talked, because right now FIRST has this 6-week build season, and then the robots get put away and you can't work on them. Well, we can, because we built a second one and a third one this year. We had a second and third robot. Second robot was for drive team, third robot was for us to test all these other prototype ideas on.
Wow.
Because one of our goals is we don't want the drive team to be penalized because we're trying out some idea on the robot or the programming group. So that's why we had this third chassis. So we had Alpha was the very first chassis we built. It had Mecanum wheels, and it got toasted right away. It was so slow. And then it turned out the Mecanum wheels were breaking all the time too.
Yeah,
That was before we knew about that problem.
Yeah, it
And
was
then-
fun to find out about the Mecanum wheels breaking problem. That was right upstairs.
Then Bravo.
What was that problem?
These 4-inch
4-inch Vex original
those-
one. Yeah, those are them.
those
Well, those
are
are the
the-
6-inch rollers, but those are the original shipped ones. And those, if you actually drive them on your robot with that version, you'll snap rollers. It happens really regularly. There's new ones coming out. Aaron Hill's promised me they have spring steel in them. They're not going to break. They can't. Basically, you have to break steel. But
Robo Reboot.
right,
Oh,
right, and we
oh,
were
yeah.
just loaning 4206. Yeah, they break.
4206 was spewing those
Yeah,
things.
it
like
happens.
every other
Uh,
man.
they have.
Were
They
in
have.
their drivetrain?
Yeah, they
Yeah.
have a drivetrain.
They
Yeah,
were just
yeah. We
spewing.
don't actually on our team. We don't say the M word. We call them collector wheels. So it happens. We were very, very mad because it was a big part of our design originally. Then we scrapped it really quickly.
Then we build Bravo, our Bravo chassis. Bravo's the chassis that's basically the competition robot, but it's like it doesn't have any powder coating on it. It's not going to look great. We're just trying to assemble and then find out that we need to redesign that one little part or something, and then we assemble Charlie, which is the competition robot, and Charlie's the one that goes in the bag, but Bravo's the one that we keep practicing with.
So after you bag and tag it, once you hit your first competition, then you can keep working
No.
on it after that.
No, you
Because
bag it
I
again
didn't
at the end of
understand.
You
competition.
bag it at the end of the competition.
Yeah.
And so you can
30 pounds
adjust.
of stuff.
Right, and you get 45 this year, 30 normally.
Yeah, it's normally 30 pounds, but this past
So
year,
you
because
get
of all
a-
the bad weather up north, they said 45.
You get a weight allowance that was formerly called the withholding allowance. It is no longer has a name, which is silly. But
Do LRIs actually look and see if people are bringing in?
we look to see if there's something so glaringly obviously bad. So like 118 is a good example. Their students
Yes.
accidentally brought in their entire spare shooter, which is a half of their robot. So I walked up to them because I know them well, and I was like, "Hey guys, that's not legal." And they were like, "Yeah, it's not legal. That was not supposed to leave the trailer. We apologize." And they shuffled it out of the venue immediately. They unloaded everything, and that was supposed to stay and not be brought in and not be used. And I made very certain that they weren't allowed to. Blah blah blah. And went through the rules and stuff.
Like
So.
like Lone Star or something, they had their second shooter right there in the
At that point, it was under. They brought it under. They pulled motors and stuff, and they brought it under.
Oh, okay.
Like I talked to them about it and stuff. They're
Yeah,
most of the
I saw
teams
it
who
on
do
top
it.
of their,
yeah.
on top of their shelves or
Right.
something. They had the shooter up there.
Yeah, they brought it under 45 pounds up.
It's 45 pounds of assembled, right? I mean,
Cots are all fine, right? Assembled / manufactured.
Yeah.
Right. So if you have something laser cut or you have something machined, you can't bring it in, but you can bring in all the spare motors you want and all the spare pneumatic cylinders you want.
You can bring it in if it's laser cut. It just counts as the 45 pounds.
Correct. But yeah,
and you can do that at each regional you go to.
Right. So if you go to 3 or 4 events, you can replace your entire robot.
Right.
There's no good way for anybody to actually check that you're doing it and playing nice. But again, there are many ways to cheat in FRC. we just don't do it. Like every team is supposed to be accountable. Don't cheat, even if it's the smallest rule. Don't cheat. There's no point in doing it. We're all trying to play the same game. Don't cheat.
I get really frustrated because like last year they would pull off the shooter, and this past season they would pull off the catapult, and we'd go to the next regional, and we would spend 4, 5, 6 hours. Not only we get the catapult reinstalled, but there'd be all these other things that have to get taken care of then as a result of it, and it was terrible. And so I was just like, look, can we just leave the catapult on the robot and build another one? The reason for removing the catapult, or 2 years ago, it made a bigger difference on the shooter, is that we're tuning that. So when we take the shooter off, and we take it back to the shop, then that's the part that's getting tuned and everything. So we get it so it's deadly accurate, and then we bring it back, put it back on the robot, and that's the one that that's the actual one that we tuned and got it doing well. The catapult's not so sensitive, so I was really.
But yeah, and it depends. There's cost reasons too. So that 45 pounds, we make sure at the end of every event, at the beginning of every event, we have certain things that we put on and we take off that we don't have spares of, because we don't feel like spending another $500 to get spares of. So some of the pneumatic cylinders and things like that, we just didn't buy spares, so we'll pull them. We try to design those things into where they are a couple bolts each time, and they don't drastically change tuning or anything like that. We try to do it. We got better. We did pretty well this year. The competition robot, we left the shifting cylinders on. We just didn't have shifting cylinders on the practice robot and just never shifted. Didn't really affect practice that much.
Well, we don't. On our robot, we didn't have shifters this year, but even last year we did have shifters. We rarely shifted.
Yeah, well, I'm talking about the up down. You had the
right,
switch.
On the up down.
That's what I'm talking about.
Okay.
Yeah, this year, last year we would take parts off, and what you're saying, and bring them back, and then we took a long time to reassemble and inspect. This year, they decided what they were going to rework. The parts stayed on the robot. The robot was supposed to go between regionals, go assembled, ready to be inspected. We reworked the parts we had on one of the robots that we had, and we brought the replacements. But if something didn't go right, we wanted the robot to pass the inspection in the first hour. When the inspectors are nice and calm and relaxed, and if maybe we'll out of part and re-inspect the quick inspection. But by doing that, we didn't have to wait 5 hours and struggle all day Thursday and no practice.
It's much easier to get through your first inspection. Well, it's much easier to get through your re-inspection than your first inspection. So get that done as fast as you can, and inspectors will be happy. Then your re-inspections, half the time, depending on who's doing it, because some inspectors are not always the greatest, will basically not look at your robot during re-inspection, which is bad. Especially if you get, I think, what did we do at Champs? There was a big issue with some inspection stuff that we're trying to clear up as inspectors. But at Champs, I had my students get re-inspected, I believe, 10 to 12 times because of what we were doing Thursday, which was crazy. Like we were shredding weight to be able to add the blocker pull. So before every match, we were in the pit taking off something or cutting something or doing something. And by the rule, you have to get re-inspected after every change. If you modify something, you have to be re-inspected. So we followed the rule to the letter, but we made a lot of inspectors very annoyed at us. And it's one of the things I've been pitching upstairs to the people in charge of. That can't happen. We either need to make the rule better or not have people get annoyed at students, because one of the two is wrong. But that's a whole different point. So really, really briefly, engineering design process, there are many, many of them. None of them are they're not standardized by any means. This one's inspired by John V. Nunes, who works at Vex, and he does one. We don't necessarily follow it formally. I'm never in the lab going, okay, now it's step 5 prototype time. But we walk the students through what their thought process should be as they're designing something. And that's the main idea. And we do this very much in depth at an event we do called Mock Kickoff, which is one of the first 2 Saturdays in December. And we basically take an old game, go through the entire kickoff, and then design a robot using this and talk about the whole process. So this was last year's game. We go through and analyze the strategy, all of that kind of stuff. Generate specs, which is kind of what they do before they do the sticky note stuff. They talk about what they want the robot to be able to do. That's in that same type of thing, right? Do we think it's a good idea to be heavier? Do we think it's a good idea to be lighter? Do we think it's a good idea to be faster? Is it a good idea to be able to push harder, right? There's a ton of trade-offs when you're designing a robot. Most of the time you can be one way or the other. You can be some middle ground, but you kind of have to decide what that's going to be. We normally start breaking some things up into the need, want, wish categories. So you kind of say the robot has to move. That's one that should be on everybody's need for almost every game ever. Some people thought that wasn't on their need in 2013, and they were wrong. You had to be able to move. I don't care that you climbed for 30 points. You should have moved. They were pretty distinctly wrong. But there's many other musts. For us this year, pick up from the floor with the ball was a must. We were pretty sure you weren't going to win events if you weren't able to do that somehow. Not necessarily. 43-34 was 118's alliance partner at Champs, and they had no ground pickup. All they could do was human player pass back. And play killer defense.
2013, we were really worried about frisbees and them being upside down.
Mm-hmm.
So we spent a lot of time trying to figure out a mechanism that would allow the robot to intake the frisbee, and it was and there were so many prototypes for this. It would either intake the frisbee and flip it inside the robot, or, and this was what all the prototyping was for, was basically a system where if the frisbee was upside down, it wouldn't intake. It would just kind of get flipped over, and then you could intake it. Right. And every time now we take that robot, and every time we do a demo, and after we're done, all these frisbees are all across the floor, and I asked the kids, I said, so look out there at the floor, tell me what you don't see. And out of a dozen frisbees, there might be one that's upside down.
Yeah.
They just didn't end up upside down.
Yeah, figuring out that we didn't have to do that took a long time. I mean, we built our 2013 robot was terrible for other reasons, but yeah, there were a lot of people who spent a lot of time on upside down frisbees. Sometime around week 3, we threw a bunch of frisbees against the wall, and we're like, oh wait, that's not a problem. Okay, good to know. Okay. Any major things? A couple things we haven't mentioned. Did we mention Karthik? I don't think we mentioned Karthik's name. Karthik is.
I saw his name up there earlier.
Yeah, probably. So most of my presentation is stolen from Karthik and JVN, who both actually work for Vex, but they've both been doing robots for a long time. JVN is on 148. Karthik, Can of Gas of Apathy. Yeah, I can say it. Is on 1114. And they do. He does a strategy presentation that's one of the best in first. Literally, they standing room only when he does it at championship. Like, it's ridiculous. But those are a couple of things that he goes over in his presentation. It's all online. You can watch the video for it. It's really good. But figuring out a way to build within your limits. Don't try to build something that Torque or 118 or some of the teams who have been around forever and are competing at that level try to build, because you're try and fail. If you build something that plays a certain aspect of the game really well, you'll be awesome. 43-34, the team I actually just mentioned, because they didn't have a ground pickup and did well this year, in 2012 did something similar. Instead of shooting the balls like everybody else, they were shooting the basketballs. They realized that on the bridge, if they took up extremely small amounts of useful alliance partners, so they built a robot that was 16 or 18 inches wide or something total, and it just sat between two robots, and then they could triple balance really easily, which in that game got you a lot of points. Literally, they just built a small robot. That was their entire design goal. And that worked exceptionally well, and they made it to Einstein. They ended up having 2012 Einstein issues, but they made it to Einstein as a rookie team.
Everybody had 2012 Einstein.
Exactly.
But for different reasons.
But for various reasons, but 2012 Einstein issues. So they didn't win the whole thing, but they were on the alliance that very well could have. Right. Wish, preferred, demand. So preferred and demand are the other ones that we get into. So some of them have categories depending on how fast you want to drive, those types of things. You can break things down. Cost-benefit analysis. A lot of that cost sometimes is, yeah, we might be able to get that to work, but how long is it going to take us to design, build, prototype, get it up to speed? Is it better to build something simpler that we can practice with a lot more if we can get it done in a week? Because for most of the time, at this point, it's better to get something on the ground on the prototype robot that we can get built and designed. Like, we want to have a running prototype robot week 3 to 4, that transition. Like, it's pretty fast. Like, we go from prototyping to all hands on deck catting to getting, one of the reasons why a lot of teams use sheet metal is because the turnaround time can be so fast. Because you plop a bunch of stuff on a laser, they bend it, you hand it back, and you rivet it together. If you don't do that, you need to figure out ways to design in sequential order, basically. So like we'll do that even with this stuff. We'll get the chassis done first. So the heavy catting all starts on the chassis originally, and then we have some more prototype time on the other stuff that's more complex, and then we get out into that and get it complete as well. But that chassis, we try to lock it down within the first week at the latest. We have it almost finalized to what we think is right, then we break a bunch of mechanisms and have to change stuff. But
when we did our the drive system, I don't know why it's called a butterfly, but it does this.
It's called Texcoast now.
Texcoast.
That's said jokingly, by the way,
So
but
the
people don't seem to
Texcoast
get
drive
it.
system. So we had that designed with the what you call them, collector wheels.
Yeah.
We had that designed with the collector wheels to start with, and knowing full well that if it didn't go the way we wanted it to, we'd just be putting Omni wheels in there instead, and we'd be happy with that behavior. But we knew our drive system like before week 1 was over. We knew what our drive system was going to be.
Yeah, we had decided to do that whole thing.
And in case you're wondering,
3 to 4 days.
you should probably just do, if you're going to do anything other than like, well, you should probably just do a 6-wheel drive system.
6 or 8, depending on
6
what
or 8.
depending on if you have to go
That's
over
what
something.
was all over Einstein, and it has been.
Yeah, I mean, Winnovation and you guys both
Right.
shifted part of it.
Right.
That this thing is catching on. We'll see how well that goes. But
The thing is, the 6-wheel drive system, 8-wheel drive systems were so simple, and they don't have a lot of weight, and if it's done West Coast style, it's really easy to switch out wheels.
we'll definitely do a little bit more on drive tomorrow to get some of that for terminology and stuff in there. One of the things you can do if you have a bunch of deciding between designs, a lot of teams. That's actually something we haven't really talked about. So I don't know who. I guess James is probably. Does James have like veto power on some of the designs for you guys? Does he get like the
James,
this isn't there, that kind of thing? Yeah.
James.
So I have it on our team, but the students design almost all of it. But at some point, you know, if there's somebody who's designing something, or if there's somebody on the team, it's really useful to be able to get robots done quickly. Basically, has to say, nope, this is where we're going. Most of the time, it's not, you know, it's not the design that I was drawing up, but you have to have somebody who's in charge enough to be able to say, it's time to stop going off into every direction, and this is what we're doing as a team, let's go. So a lot of that is build consensus. You try to build consensus with the team as much as possible. Most of the time, it's not an issue. I don't think in the last couple of years it's been an issue. It should have been in 2013 because that design was awful, but it wasn't, and everyone was like, "Yay, this is great." But you know, things happen. But in general, getting everybody on that same page is hard. So finding somebody who can be that main design leader and do that is very difficult. And when teams don't always have that, and you end up in not necessarily arguments, but just two people who are very much, this is where we want to go, and they're taking the team in different directions, your build season doesn't always work out very well until somebody kind of relents.
Yeah, so the build season is only like 45 days.
45
right?
days, exactly.
And then probably take 3 or 4 days for the team to get to know what's the problem and what's, you know, the brainstorm session. And then afterwards, they need to
Depends on how fast you can go.
have their team leader coming out of the.
I mean, we
already have our team leader.
Oh, okay.
We start, yeah, your team leader should be, who's going to be doing that should be based on how your team flows.
We're using, that's what off season has gotten to be. The off season has been it takes extra time, but we find out who's capable of doing things. Sometimes what'll happen is we'll give people projects, kind of see how they handle them, and then that'll let us know if they can do that during the regular season or not. But we already know who our team captain is, team leader. We know who our electrical lead is. Mechanical lead hasn't been announced, but we know who it is. We don't really know who our CAD lead is, so we're doing a bunch of, we're doing some exercises, kind of like your classes, except more independent work, with us providing feedback to them, to try to get a lead CAD. We've always been fortunate to have at least one student who was like just stellar at doing the CAD work. And right now we don't
you have to train them up. They have to be trained. It's easy to be in charge because everybody wants to be in charge, but it takes a lot of work to be in charge.
And
learn how to work.
I mean, that's what we
And-
use. I mean, the summers is to kind of shake them down a little bit. So they aren't always announced, and I'll be sitting down with Matt later. He's the team captain, and we've already talked about a couple of the kids, and we'll be talking about some other kids and what they want to do. And some of it just depends on, all of a sudden I've got kids saying they want to do things that I had no idea. Cause we didn't have a good finance person this past year, and our ledger showed it. It was a mess. We couldn't keep track of it. I mean, we knew kind of how much money we had because we always had plenty of money in the bank. That was our bookkeeping. So I just balanced the books, and now we have a student who says, oh well, I don't see that there's anybody stepping up that's going to do that, and she would kind of like to try it. I was like, okay, because we need somebody.
I've tried the last couple of years to, like mid-season or whatever, have some one-on-one sit-downs with students and figure out like, are you reaching the goals that you set for yourself, and are you happy with what you're doing, or are you interested in something more? And just try to have one-on-one conversation with them, like, are you doing what you expect to be doing? And sometimes they need some extra pushing. They're like, well, I wanted to do this, and as the mentor, you're like, well, then why aren't you doing it? But sometimes they just need that extra push.
You said mid-season, do you mean after the kickoff?
Well, so like I'll try to have a mid-season talk with them, but I also, before the season starts, I'll try to like, I usually hand out a little sheet of paper like, what are your goals for this year, things like that, and it's just like a one-pager of just 4 or 5 questions, and try to set some expectations for individual students during the year.
I don't have it written down, but I talk to the kids.
Yeah, exactly. You spend
What areas do
time. You
they
spend
want to
time
work?
with a bunch of the kids, and you
You
figure
do
out who you
spend
have
a
to
little time
push.
with
Yeah,
them.
you get to know them really, really well. But and team structure is entirely up to you. They're all different. We're probably the most judges have called us disorganized, which I dislike, because we have no set positions on the team. People don't understand how our team works and gets things done. But amazingly, it still all happens. We get a robot. We get people who one day are doing the CAD for something, and the next day are doing the media because they're able to do that because they're whole people. So if you can do it and not box people in, great. I've had issues before where leaders didn't lead and teams' whole seasons were put in jeopardy because of that. So we haven't found the need for it, so we didn't do it. So it's up to you guys how you do team structure. That's team to team, it changes. But
For me, it's
lots of
like
things
if we
to
have a
work.
good team leader, and I've said this at our end of year banquet, if we have a good team leader, and this is true for all the team leadership, all the sub-team leaders, that means I'm not doing anything.
Right. So
That's what happens.
and in no way does it say that we don't have leaders on the team, because that would be ridiculous. We absolutely do. But it's the people who are there and stepping up and being the leader that don't necessarily, I don't title anybody, but everybody, if you ask them who are the leaders of the team, they're going to tell you. Like, that happens every day a year. And they have different, if you ask who's the programming lead, there's no one given him that title, but everyone will tell you Matthew does the programming. Like, it doesn't, so it works out.
Like I said, we're different in that we do have a sub-team leader for programming. We have a programmer in waiting that works with him. We have a senior that's not a programmer in waiting, and we're just, I have to sit down with him and, talk about how can you help the team. One thing that we're doing is we're one of the beta teams for the Robo Rio, and so that's something I've talked about a lot, that this senior programmer, because really when you're programming on the robot, and we've tried it in different ways, there's pretty much just one person that's programming the robot. That's that's the only way that's really worked for us. One person programs it. Sometimes, well, that programmer in waiting, that's the person that can fix problems when the programmer isn't there, pretty much.
We normally have somebody who can fix stuff, and then somebody who's on drive team is able to do some amount of code every year. Like, they have to be able to change the right variables and things to make the robot work.
Well, on ours, it's all parameters that they just punch in.
Right.
Change
Like,
the
on
number.
occasion, something will mess up, and if they happen to be there, they can do it on occasion if they need to. But we make somebody on drive team learn a little bit of code. But yeah, most of the time it's almost
Yeah,
one,
so
and then
you
I'm
mentioned there's
version
drive
tracking. So.
team. So what are the teams supposed to do?
Oh, so
Is
drive
there a
team.
what
Drive team
else?
does have to be set because that's it doesn't have to
Well,
be
it doesn't
set,
have to be.
but at any given match you only have
You could
4
be-
people down
could
there.
Be disorganized.
Okay.
Right. You could be disorganized and cycle people through. Which, by the way, don't pick drivers. Stay with them unless they're not performing for some reason. Again, practice, practice, practice. If you have people rotating through drivers, you're never going to practice. They're all going to be bad every match.
How do you choose drive team?
Ours are pretty natural. Most of the time, the people who are going to be on it, you normally get 3 or 4 people who are the ones who put in the most time, who have practiced with the robot the most, who are going to be able to put in time with the robot. Lately, well, by lately I mean all 3 years I've been on Spectrum, it's been seniors, which has been annoying because we haven't kept anybody. I would actually rather it be a younger person, but they haven't, at the time, haven't been putting in the dedication to be able to be those people. In the past, until this year, we've had a student drive coach. I moved to coaching at IRI last year and stuck with it through the season, which works to keep some of that going and a little bit of experience on the field. Because most of the time, it's actually me working with other teams on the field than my own. Those 3 do whatever they need to do.
Okay.
Question?
You said don't cycle several drivers through.
Yes.
But from experience, we think you should have at least one backup.
Correct.
Because the week before national, our driver thought he was big and told us because his brother wasn't getting to go that he wasn't going. Well, yeah, his dad got big. And then when we said, okay, fine,
So this is the control system we've been using for the last 3 years. The one that was used before that was the same, but it had 8 slots. This is an industrial product that we make. We've been making it for about 12 years. You'll find them on diesel engines that go in oil fields, marine, things like that, windmills, and basically these modules are your I/O selector, and they can either do analog, digital, combination. There's like 100 different modules you can buy depending on what you're measuring. So if you're monitoring strain on a bridge on an overpass or something like that, you're not going to use these modules. You'll use the high gain, really sensitive modules, and they come in different sizes because people have different amounts of data points and things like that. Anyway, these are industrial temp, so they'll go to like 70 degrees Celsius all the way down to like -30 or -40, whatever it is. Strong shocking vibe and all that kind of stuff. First came to us and said, hey, we want a control system, what do you have? And we kind of just said, well, here's what's in our catalog, and that's kind of what they picked. So it was not designed for the first robots. It can be made to work. It works quite well in some sense. But I don't know, like I was joking with some of the people at Championships, and like we've never been asked to put a 3-wire friction fit connector on any of our hardware ever. And that's all you see on these robots, these PWM cables. They use them for everything. And so like they don't want screws, and we don't. So there were definitely some mismatches, right? So that's why some of these breakout boards and things like that were quickly spun off often by deck engineers. They sort of made these little bridging modules and things like that. And so basically these are the I/O modules that are on the robot. This is the controller that's on the robot. Just to get a little technical, it runs the VxWorks operating system. It's the kind of thing that goes in airplanes and missiles. It has an FPGA on board to do the heavy lifting for the I/O. It actually doesn't get to do a lot on the robot right now because these I/O boards are so slow. So the digital and analog and all that kind of stuff is really kind of limited by these modules. But it's kind of a costing issue. We have to give out a lot of these modules. So I'll start passing this around. And I realized I should probably also tell me a little bit about National Instruments and myself. I skipped over that part. We make things like that, and I went for them. So I worked for National Instruments for 24 years. We're located in Austin. We sell things into research labs or manufacturing. That's basically what we do. So cell phone testing, bridge monitoring, all kinds of stuff like that. Our hardware, our software may get used in those situations. We don't do a lot of control, but in research labs we will. If people are controlling lasers, one-off kinds of things, they may use our stuff for control. But it's not like, we don't replace PLCs that often in manufacturing, things like that. So I am by trade, C++ programmer. I worked on LabVIEW for like 20 some odd years. LabVIEW itself is also a programming tool, so I'm a programmer who makes programming tools. I also, National Instruments has been involved with Lego since the late 90s. They showed up in 97 or 98 with this thing called RoboLab, which was, they had taken LabVIEW and made another LabVIEW on top of that language called RoboLab with Tufts, this professor from Tufts. And I was managing at the time and working engineer, and we agreed to help them make that better for the kids because they were trying to give it to 6-year-olds and 7-year-olds. So in 2004, I kind of fully transitioned over to do educational software, and have been working with Lego and other universities and things like that ever since. And so that's one of the reasons I'm heavily involved with FIRST, is because this is another outreach educational thing. So we're a sponsor of FLL, along with Lego. The Mindstorm software that the Lego kids use, that is LabVIEW. That's something that I wrote with 4 other guys. We wrote the firmware, we wrote the drivers, we wrote the language, all that kind of stuff.
Did you do the
Lego.
EV3 stuff?
We also did EV3, yeah.
I like the changes.
Yeah, I do too. Yeah, so we also did the junior fellow stuff. We do. So I don't know if you see it very often, but it is built for like really young kids. So it's an even simpler language. So that's what I do in my day job. And meanwhile, National Instruments doesn't really make much of a business out of the educational stuff. We do sell to universities, but that's one of the reasons why we work really well with FIRST, because we want to promote engineering and science, but we don't really feel it's not a business for us. So we're willing to donate and give away and help a lot. So. Okay, so back to the hardware and the controller stuff. So this, believe it or not, is a naked one of those, but it's the 8-slot version. And this is our sort of launching pad from that to what I'll show you in a second. Because this is a compact Rio dev board, which is why it's like, you know, mounted on this thing, and so we can get access to all the pins. And this is the full industrial version that has, you know, USB host and 2 dual Ethernet ports and extra serial ports and the redundant power supply and all that kind of stuff you want in industry. But on the back, this has the new chip and it runs the new operating system. So it's the same. So like hardware-wise, it's like that, but software-wise, it's the new stuff. So this is what we used before we went to alpha. And you know, that's what, if you take the screws out of the back of that guy, or clean one of the existing C-Rios, that's what it will look like. For alpha testing, we actually managed to get boards for, we actually went out to 9 teams. And this is what the alpha teams, oh, I guess we got the screws. This is what the alpha teams used. We had some 3D printed plastic, but most teams didn't get those. I think I have a screwdriver somewhere. Screwdriver. There we go. Pick out this power, and then I'll pass this guy around.
So I guess the weight actually reduced tremendously.
Yeah. So this is the same controller with more I/O, and it doesn't need most of the breakout boards. So you'll notice we finally made a product that has the 3-pin friction fit connector that first is used forever. And I've got to tease it apart. There we go. It was like printed around the board basically. So this is the new one. So to tell you just a little bit about it, the Zinc chip, X-I-N-Q, I think is the way you spell that, is a Xilinx part, and that is a combination of the processor and the FPGA. So the FPGA, by the way, is effectively it's programmable circuitry, right? So this is where we get to make hard real-time stuff that talks to the I/O, and usually what happens is you have your raw I/O over here. You have your basic processing, which might be filtering or accumulation or things like that, or counting. And then you have your CPU. And CPUs are brilliant, but they're not very good at being on time, right? Even with interrupts and even with all these other things. Millisecond doesn't very long for a processor, but these FPGAs run at 40 megahertz, so they run sub-microsecond. And you can do things every single cycle. So you can use them for all sorts of really cool things with I/O. They're very, very fast and very reliable. And they're reprogrammable. So, you know, we started putting them in our products years and years and years ago, mostly for workarounds and bug fixes. You know, IBM would ship a machine, or Dell would ship a machine with a problem on it, and it's like, well, sorry, you work around it. You know, so we'd have a board, and if we had an FPGA in there, we could actually modify it in the field to work around those problems. And so we started using FPGAs for that, and they got bigger and more capable. And now we rely on them for a lot of the processing power on our boards.
Kind of like boot loading, is that the right for PIC chips? They do something where you can basically upload and upgrade to like a firmware upgrade, I guess.
It's something like that, only we literally like replace a chip on the board. It's almost like a hardware swap out. This chip used to be a 4-bit, counter, and now it's a 6-bit counter. Why? Because we wanted to change it. And again, it is hardware deterministic. It's as deterministic as your clocks are. There is no software, no processing, no OS, no interrupt, no nothing going on in that hardware. It's a circuit.
Bunch of gates.
That's exactly right. So that's why we like and use FPGAs. Unfortunately for FRC, we have to keep that part closed because that's where the safety aspect is encoded. And at this point, we aren't able to combine student code and our code. We basically have to act as a drawbridge, right? When they say the field is safe and you can go up and touch the robot, we really have to ensure that. So we have to keep the FPGA closed. Someday, we'd really like to expose the partial reconfiguration where we would allow teams a certain number of gates that they could actually modify for their robot's benefit. But at this point, that's not possible. So I always get asked that question, and unfortunately, that's still the answer.
So, the real RoboRio is in here. This is what we're going out to the beta teams. And this is the real plastic and the real silk screen and the real lots of stuff. It's actually connected, so let me do that first. It's my Velcro on the back, and so in fact this is a Rev C that's been reworked. The real ones that are going into beta are, I believe, Rev Ds. So
You don't want to break it?
Hmm?
You don't want to open it, or?
I can open it, but it looks almost identical to the other one. They're, you know.
The software update, or what's the difference between the
No, it's hardware differences, but you probably wouldn't spot them. Everything's tiny on the board, right? So no, some of the changes were actually to get rid of a few glitches during power cycling and things like that. And they've so in fact, I'll explain the kind of things that we're trying to make the board survive. One of the design goals was to allow any pin to be shorted to any other drive, right? So.
Sure it's not because of the real-time operating system's problem?
No. So you can take a screwdriver, take power on it, you can go up and down the pins and all that kind of stuff, and you won't reboot it, you won't short it out, you won't smell any smoke, and you can do that sort of thing. So that's what it's supposed to do, and that's what the tests do. Turns out that this version actually does have a little problem, though. We discovered, ironically, when we had a fire drill. I was sitting at one of our test stations, and I pulled the USB cable out, and I threw it over on the other side and set down my laptop, and I walked out. And well, USB cables have a conductive connector, right? And this landed on one of the motor controllers and sat there while we were outside, doing the fire drill, and burned up the board. So they actually reworked it to where it would survive, the 40 amps through. So it's supposed to survive. That one was pretty challenging. They said that the diodes in there actually did look like LEDs.
So what did it short across? The USB?
Yeah, so this was going to ground.
Gotcha.
I mean, so sorry, this is the external one is ground, and it was going to the 40 amp supply on your motor controllers. So they're trying to basically make them very robust. Yeah, because your laptops won't survive that either.
I'm sure some team will find a new one.
Absolutely.
That's what cheap Delphi's for.
And we will hear all about it. Engineers are not perfect.
Yeah, the old hardware was pretty good. We used the old power distribution board as like a spring dampener 1 year, and it survived the whole time. So you can do.
So this is what I brought hardware-wise. There's other aspects of the control system which I will just sort of have to describe or open up the slides. So I think what I'll do is I'll go into some of the slides.
And we're going to get this in the next kit, right?
Yeah.
Okay, good.
That last one
It will be in that.
is identical to what you'll receive, hardware-wise.
What's the probable cost of this if you want to buy a second?
So that product costs, what was it? Is it $415, $435?
Yeah,
I think it's
I have a
$435,
receipt.
and we're choosing to distribute it through Enmark.
Yeah, you can pre-order them now.
Yeah, and so price-wise, that is the controller. I don't exactly know if he throws anything else in the kit, and it has some of the breakout words and stuff like that integrated in.
No, I think what you get for it's $443.55 shipped to the school. So, and that's just the RoboRio itself.
Not the pneumatics part?
No, that all is going to be separate. They had a somewhat cost estimate at one point for those. I don't remember what they are. They weren't as bad as an $80 sidecar though.
Right.
Yeah. Is this still kind of like the August, October ship date?
Yeah. Well, the beta is just about to start, so we're still a little ways off.
Okay.
I mean, and they're being manufactured, so we'll be working around whatever gets fixed now, wherever it gets found now. But yeah, I think I'm not a part of the hardware team, but I think that's the date we're looking at.
It says early December 2014.
Wait, what day did you say? You said August?
At championships, they were saying they said.
I think some
they-
components may be available in August from across the road, yeah. Okay, so I have pictures of some of the other pieces, but what I'll do is I'll try to quickly go through some of these slides. I presented this in Michigan, and a lot of this is just talking about the process and just trying to be open about it. And there were a lot of students there. So the audience was really trying to explain to the students, you don't just go to Amazon and pick a robot controller, you have to design it. And how does that happen? Yeah. And so some of this, like I said, I'll go pretty fast. But if you see something you want to talk about, slow me down.
I like to watch the line.
Yes. Yeah. That's the easy part. The one part that takes a year. So, and this is a little more interesting when you show some of the dates. Because first announced the RFP in August, and they only gave a few months to respond to it. So basically you have to go through all the business aspects and all the design aspects, and even figure out if you're going to do, like, does our business do we have the right product that's in the pipeline that we can adapt to this? And does it make sense economically for us to do this? This is the document that was the RFP, and this was an overview of the existing system. And, well, actually, no, this is an overview of the system that we proposed. So, this is what they asked for. They asked for all of this I/O, and they still wanted the rest of the control system to look the same with the driver station external. So, sorry, it's been a couple months since I gave these slides. This was the rest of the schedule, like delivery dates for beta testing and alpha testing and stuff like that. In fact, we can see how we're doing on schedule. Yeah, we're not on schedule. Big surprise. So one of the things that came out of it was we drafted a rough proposal, spoke with some mentors, and we kind of talked around to see who else was doing things and who else was interested in doing things, and decided to partner. We actually got together with Across the Road and Andy Mark and a few others, and decided to be open about it and say, this is what we think this is the part of the system that we think we can do well. How about you guys? And there's people in automotive and people in aerospace and people that do all sorts of things. So you aren't necessarily going to do the whole thing better than everyone else. So we ultimately decided to continue partnering with WPI for some of the software tools, with Crossroad Electronics, and with Andy Mark for distribution and some input on the design. We wrote a proposal. We took things out that were previously in the Roborio. So pneumatics, we almost entirely took out. Part of the reasoning there was if you're going to do it on your robots, you really need quite a few capabilities. You don't want just 4 channels, or sometimes it's better to have 0 or a lot than have 2 of something, right? And so rather than raise the price for everyone, even if you're not using it, we decided it would be a buy-in thing. You would opt into pneumatics, and so that's why it's external. We were also looking for those things that tend to break. We don't want any one component to break, but if something's going to break, let it be the less expensive thing. So the I/O had already been, at first had already done some accounting and had asked for the I/O count. And we did some modifications on that, and we're trying to get it to where most teams would not need anything but the Roborio. But then the other pieces are perhaps also chainable. So if you are going to do pneumatics, or if you are going to have other devices, you can have multiple of something else. So it scales better by having a few boxes that are external. We have a lot of expansion options. So this has native CAN. It has, it's a USB host. It's also a USB device. It's an Ethernet device. It's an I2C and SPI and serial. The serial looks funny, by the way. You'll have trouble figuring out which one's which. And it also has this new thing called the custom electronics port. So that's actually the thing that's sitting on the top. I don't know where it is right now. Yeah. So anyway, it's a wide breakout board with 64 pins. That is the other half of the I/O. So to meet first requirements, we only needed about half of the I/O that's in our product. So we chose to leave the other half up to teams, right? So we didn't do the breakouts and the 3-pin connectors and all that kind of stuff. So we'll basically let teams decide what they're going to use. Do they need more encoders? Do they need more digital ins, digital outs? Do they want more PWMs? What do they want to use that extra I/O for? Part of this was also to encourage kids and teams to design their own circuit boards. The software, the printing software, and the design software is there. We're also going to supply some of that. One of our subsidiaries is EWB out of Canada, so we'll have some products, and they can, the templates work in other products too if they want to use those for design. And so you can actually make your own little circuit boards that do your sensor integration or simple little things. Maybe you just break out. You just have a mass termination or something like that you want to put on your board. So we intentionally didn't finish part of it. It's a design project, right? That other half of the I/O is yours. You have to decide what you're going to do with it. So we kind of like that idea, right? This, by the way, is based on a product that you might see out there. It has only been out for 1 year. It's an academic product that sells at universities called MyRio. And Rio is our term, by the way, for reconfigurable I/O. That basically means I/O with an FPGA that can change its personality. So the MyRio is this college student, thing. It actually fits in your back pocket, and it's basically the RoboRio without all the I/O broken out. It has 2 of those custom connectors. The RoboRio has 1 because we took one of them and used it for first I/O. So that's where it came from. And like I said, we're including some brand new products from across the road and software from WPI that's being updated. That was basically the summary of the proposal.
When does Cross the Road release their products?
So I think some of those are earlier. I don't have the details, but I believe some of theirs may be purchasable within a few months.
Okay, because there's nothing on their website the other day when I checked.
Yeah. They're a very small company.
I was hoping for a teaser.
Yeah. Well, they have been showing it off. They showed it off at last year's championships, and they had them at championships this year.
Well, I saw them at championships this year.
Yeah.
That's why I went to their website to look.
Yeah. Yeah, they're actually pretty close, but they're both working on the product, so I don't think they bother talking about it very much. And I think they'll probably also sell mostly through HandyMark. But I believe they're also going to be selling some stuff through Vex, so I think their stuff will be easy to get a hold of. So this, speaking of which, is another piece of the control system. We only have 2 of them, and they're on our test system, so I couldn't bring one. But this is your power distribution panel, or power distribution board is what they call the old one. But this basically is where your battery goes on here. So this is your super high current side, and these are your snap action breakers, and these are your main circuits that go out into things for your radio or whatever, or your motor controllers. So these are usually limited to 40, and these are limited to what, last 20, 30?
20, 30, yeah. You can put 5 and 10 in them legally.
Right. So there's a couple of additional features on this, a couple of changes to what's on over there. The mounting screws here have been reversed. So instead of having studs that you mount bolts on and people twist off, it's actually the other way around. So you have bolts that go into threaded inserts. So that was one thing they changed because they did see those break off.
Are they SAE or metric? Are they SAE or metric?
I believe they're still metric. I think it's really hard to get. They were saying it's really hard to get.
They're metric. They were impossible. I think they're M5 or something. They're M5 or M4, but they're impossible to get the stud for. Like that's why those ended up being metric too. That was one of my specific questions to them. I was like, why is it still metric? What's happening?
Yep. So let's see, on this end over here, there's LEDs and CAN. So it's a little odd that effectively your big breakout panel has CAN on it, but what that's there for is monitoring, current monitoring and logging. So the robot will actually know how much current every single circuit is pulling. So we don't have a lot of the diagnostic software there yet, but if you have some questions about your robot, is it binding, is it doing this, is that driver driving different than that driver, why is that one faster than that one? You have a lot of data that you can pull back circuit by circuit here. So we don't yet have all of that, even the beta teams don't have it, but that's one of the new features for this power distribution panel.
So, so when you say you don't have it, is it not putting out the data, or do you not have the software written for it, or which way?
It's now on the CAN bus. That's a recent thing. I mean, the protocols, the specifications, all that kind of stuff still, it's in the board.
Okay, right.
But, you know, it stayed in the board for a while, and now it's on the CAN bus, and now it's not in the network protocols to get back to the driver station, but soon you'll have it logged on your laptop, and you can just look at it during the match.
And that'll be, RoboReel will be able to see it too, right? We'll be able to, it's all there.
On,
so,
in code, yeah.
so
So it's not clear to me, because we don't have access to it, it's not clear to me whether this is actually good for control of a motor. You can read your current draw and, you know, determine your power that's going to that motor. It may be fine, there may not be enough resolution. It is on your robot, there is an API that will let you read your motor draw on your robot if you want to do your own diagnostics and logging. You have a couple of dedicated ones, a couple of fuses, things like that. That's basically what the power distribution panel looks like. It's a little bit smaller and a little bit lighter than the existing one and a little bit cheaper. Any questions about it? Okay. So this one is the pneumatics module. I said we left some things out of the RoboRio on purpose, and this is one of them. We decided to design with Across the Road a pneumatics module that actually does the compressor control, the compressor power support. It provides the power for the compressor, and also does the circuit control, the pneumatic control over CAN. So
power for the compressor closer here?
Yeah. This turns on and off the compressor based on pressure.
The relay's built into that.
Yeah, the relay, the spike is
the
built into
relay's
this.
built into this.
So this is about the size of a spike, but it does everything else too.
Yeah. Things that cross the road, or do they test the crap out of them like United does, or does?
Yeah.
I mean,
so
Yeah, I mean, it's you know, Mike.
And if you've used the, you've seen Talons, right?
Yeah.
Oh yeah.
They did Talon, and it's the most robust thing. I haven't broken a Talon yet.
I just want to make sure.
Yeah, I mean, no, but we picked them because we think they're doing a good job. And yeah, we're watching each other, challenging each other.
I know you guys like throw C-Rios off the top of buildings and stuff.
Yeah, we do.
So how much is that other module gonna cost?
What's that?
How much is that module gonna cost?
So I don't have the details on this. Somewhere I have a flyer. I can make guesses, but I'd rather not.
I'll just Google it.
Is it like $100?
It's under $100.
It's under.
Okay.
This will probably be in first choice.
Yes.
I'm willing to bet.
I think they will be.
Okay, good.
And this is the RoboRio. I just talked about it. So here it is, you know, in a render before it was real. So as I said, the serial is one of the funny. They use the funny connectors. Yeah, there. So there's a few different connector choices on here, and you'll notice CAN is not the RJ connectors anymore. Those weren't as successful as people thought they would be. So we're now down to something a lot like the Vago connectors, the press fit, the spring-loaded connectors. So it's bare wire. You insert it, and it's retained. Mike likes to sling it around like a yo-yo and show that it won't pull out very easily. You'll break the wire off first. So anyway, that's the RoboRio. This part up here is the custom electronics port. So that's basically the I/O that teams get to either ignore because they don't need it, or customize because they built their own board or bought a board that will give them what they want for that particular year. Yeah.
I know.
I saw this. Sorry. Go ahead.
To tie down the RoboRio to your robot, you can either use zip ties through those little holes. There's also screw holes in the back. There's metal inserts in the screw holes.
Yes.
Those aren't ground, correct?
Those are not ground.
So, robot inspectors don't need to worry if you screw it on. Robot inspectors don't need to worry about ground.
Yeah, that's pushed into the mold, and it doesn't touch anything internally. It's isolated. So, and it's the same size as your standoff. I wouldn't use standoffs, but so that's a 440, I think.
Why not use standoffs?
I'm just saying that. That's not why we chose
Oh,
that.
I'm just saying maybe because like we stood up, like standing off the PD board was one of the best things we started doing. They were awesome.
The standoff, I'd be afraid.
Yeah, I wouldn't raise this. I mean, really, the real reason these are here is to mount it to a mounting plate. So for people to take a piece of Lexan, a piece of Luan, or whatever, make their own mounting plate so that it fits on their robot with their bolt pattern that they want. Also, on the sides of that, they can do their own cable routing and cable retention and things like that directly built in. We didn't want to build things into the controller, so people can't modify the controller. you won't pass inspection if you cut this in half or shave it. Or,
You also have field communication.
people, so we have a Robo C-Rio. Somebody said, wow, this is heavy. So we have one. So I put it on the middle, and I think they put 50 holes in it, and they did all kinds of little channels and things like that, so it was still structurally sound, but that didn't pass inspection. So they destroyed, about an $800 piece of equipment to save about 15 ounces. So.
Because I'll be back here.
Yeah. So anyway, because you can't, you're supposed to use this year to year, and you're not supposed to modify this part. You're not supposed to modify your motors. There's other things you're not supposed to modify. So instead of building something in that you would just have to work around all the time because it's not your system, again, we let you finish it. It's part of a DIY project. So you have mounting screws that can go onto your plate, which is, your team uses zip ties, your team uses a chip clip, your team uses something else. Some of the teams won't use any cable retention. It'll all just be a bird's nest on top. We know that.
Inspection's fine.
So that's one mounting option. Yes?
Explain to me USB host versus USB device.
Certainly. So the USB device is used to image it, to flash it and image it, to program it. So when you plug this into your laptop, like a printer or like a camera, what happens is this shows up like an Ethernet device on its own private little interface. So all the problems we've had previously about the laptop shutting down the interface when this reboots and all that has gone away. And so the most common way to reprogram it, and the pretty much the only way to image it is with a USB cable where this is the device. This allows it to talk to cameras and USB devices that you plug into this, where this is the master and these are the devices. So in fact, the cameras like this, this is a camera choice that you have. So this is just Microsoft Facecam. That's the brand name they use. So you can use this instead of the Axis camera. Right? So that's what the USB host gives you. You have two of those.
So I could put a USB stick on there for data logging.
Yes, yes, you can use it for storage. Right? In fact, in the alpha, that's what the Java teams had to do to boot. They had to have a bigger flash drive, a bigger partition for their booting, their swap. So that's what they used. But yes, you can put a hard drive on it. That's a flash stick. You can put a keyboard on it. You can put a mouse on it. You can put a joystick on it. I don't know what people are going to put on the robots. It's running Linux, so if you have Linux drivers for it and you can get them installed on here, you can program it and read it and control it.
So native. I mean, is it not providing neat drivers for keyboards?
They're probably already on there.
I imagine they wouldn't be.
Yeah, the cameras and stuff like that are already on there. So
it's a relatively standard Linux kernel.
Now, you mentioned that the USB device ports are going to be primarily used for imaging and programming. Is over network imaging and programming still supported, or is that being removed? Over Ethernet, I should say.
the imaging, I don't think is going to be supported, not officially. It might work over Ethernet, but teams had a lot of problems with laptops depowering your Ethernet chip as soon as the C-Rio went away. So that's one of the reasons we did the USB device. And it's faster. It's faster to just plug this in and you know it's going to work. You don't have to change your IP address and all that other kind of jazz. Right. Yes?
Yeah, so I see that you also have accelerometer in there. So
Yes.
is there any API already installed that you can program that?
Yes. Yeah, so there's a mark on the front. So this is where it's physically mounted inside the device. So there's a 3-axis accelerometer there. So if you do want to know if your robot's tilted and here they have a ramp or something, or some other means of yes, you can read the accelerometer.
So you have
Whatever you want to do with
you
that.
already have the driver or API developed for that.
And we just didn't depopulate it. It was in the My Rio so that people could have the fun little demo where they shake it and tilt it and do all that. We just didn't pick it out.
No gyro though.
No gyro, exactly. I was gonna say that's the one that would be really useful in a robot.
That may
Everybody-
be one of the boards though that somebody puts
Exactly.
down is going to be a
Yeah.
9 degree of freedom type thing at some point.
Since we assume in December sometime, hopefully, assuming there's no delays. How much, and you have to either buy or make boards. How much can you run a robot right now without having to buy any extra boards? Do you have to buy or make boards or?
Oh, no, you have, the IO, so you've got 10 of the DIOs, 10 PWMs. You're a little bit light on analog, but in fact, these pins are already some of these pins are already your analog pins, so you can just put a cable on there.
No, I'm just thinking because if they come in mid-December,
Yeah.
it's kind of rushing it into
Yeah.
into build to having to, for some people to experiment into a new system.
Yeah, and during the beta, I suspect a good number of the vendors and teams will start to put out designs and products.
Yeah.
In fact, the rules are still being written for safety issues because you don't want to be controlling motors off of an Arduino that you attach to this thing. You may want to, but the people around your robot don't want you doing that. So.
But in terms of that running a robot, if you handed that to me in an hour or so, I could get that plugged in on that robot with the old power distribution stuff, running everything but pneumatics.
Yeah, it's very compatible.
Actually, pneumatics, you've got 4 relays.
You do have
Right, I mean,
relays.
quickly, with the setup I have right now, I wouldn't be able to do it. Like, I'd have to run wires for relays and everything else. That would control everything else just by swapping cables.
But you couldn't run pneumatics with that legally because.
You could run it to spikes. You could.
Right.
But you're only going to have 4.
Right.
So
So,
So it has some amount of pneumatics, and you're going to have to use another one for your compressor, and you're going to have to pull things back and write code here to do your compressor. So you don't have to buy the PC out to do pneumatics. But how many teams are only going to run a few channels? I mean,
No, I was just thinking about like you have to have the pressure switch in there and stuff.
right.
Yep.
So, okay.
And that's back to all moves. That's all digital I/O.
Okay.
So this is just, it's 256 meg of RAM, 256 meg of storage built in. So yes, you can do the memory stick, but that's quite a lot. And you can easily FTP or take things off afterwards, but that's a lot of storage. These are the 3 languages. That's the OS. It's a dual core processor. It's a lot like what you get on an iPad or something. And it also has the Xilinx FPGA. So I don't know how many gates that is, but it's more than is in the C-Rio.
What was the storage on the old C-Rios? Was it 256 as well?
On the 4-slot one?
Yeah.
It maybe 256. Yeah. I can't say
I
for sure.
filled it up after 5 matches.
Oh, cool. I love seeing teams log what the robot's doing. I'll talk about a little bit of that tomorrow, I think, with some of the software features and driver station and whatnot.
What was really interesting is what happened when we filled up the memory.
It's not.
And thank goodness, I think it was one of your guys helped us with that.
That was me.
It's not good. It's not good when that happens.
It took 2 minutes for the C-Rio to
It's
start.
impressive you managed to get it to the field doing that. Like, we've done that where we had something running log in shop before. We've never done it on the field.
Well, it took like 2 minutes for the C-Rio.
So some of the
Yeah, it
physical
takes a long time.
and electrical stuff, this is not industrial temp. That's one of the things that, it's really expensive to buy industrial temp components. But it's good enough for general usage. It's lighter, it's smaller, it's more of a tortilla than a loaf of bread. Well, it's funny because when you had those conversations, the old i5 controller was, smaller and lighter, but people put these in rockets, like model rockets, and you can't do that.
I have
with-
mine in our wheel well.
Exactly. So it's actually not a bad form factor, but anyway, people prefer the pancake or the tortilla. So. There's a lot of current monitoring and monitoring of the internal rails, and if you do one of those shorts and you have something fall across and whatever, or somebody puts something on that shorts the pins, you'll get an LED notification and you'll get an event in the software. So there's a lot of monitoring and stuff like that. Those conditions aren't supposed to happen. The brownout was actually what a lot of the most recent alpha test was about. We literally had robots that ran 5 matches on the same battery until they couldn't run anymore, and pushing against the wall and doing things like that to try to verify what would happen. So basically trying to make sure that it would not reboot, any more than absolutely necessary. So what's that?
It would just die.
Well, yeah, it would just kind of stop moving, and it wouldn't reboot the Robo-Rio. That was kind of the goal. Is if you shut all the outputs, it doesn't take much current to run the Robo-Rio, and so then you would You know, you just don't have. You have a robot that won't move. You know, it just constantly browns out and does that.
That's
But
called a big clue to change your battery.
but before it does that, it only does it when you push it in the wall, and then it starts to do it more and more and more and more until, like, yeah, it's kind of just sitting there. Here's the I/O details, lots and lots of numbers. You know, you can find all this stuff online. I'll show you where you can get it if you really want to get into it. But it does have a good accelerometer on it. Like I said, it's a little light in my opinion on analog input, and it's not good for pneumatics the way it is. But that was a good trade-off because we made a pneumatics piece. Yeah.
No, I'm just saying that's a design trade-off.
Yeah.
I'm not upset by it about that at all.
Cool. Okay.
So it has, well, how many analog inputs were on C-Rio?
There were 8 on the module.
So
and
there's no, I mean, it's the same thing that we were.
Yeah.
There's just
you
only
could have
4
2 modules if you wanted.
Okay.
And
I guess we never got to that point.
and only 4 of them are 3-pin connectors on the RoboRio standard. The other ones are up in your
on the MXP.
expansion.
But analog output, was that anywhere on the?
Yeah, there were no analog outputs.
Has anyone thought of a use for it yet? Because I still haven't.
Buzzer, I don't know.
Fine.
Annoying.
He'll find
I've thought about it. I don't have a use.
Find a way to run the motor off.
Gotta be something with flashing lights.
So you mentioned mounting earlier. We also put in, you know, I've got Velcro on the back of mine. It's actually to hold it inside my bag. But Velcro is a pretty good way to hold your RoboRios on your robot. You know, really, I mean, let's face it, if your 12-pound battery hits it, it's going to come off anyway. It'll break zip ties. It'll not get loose.
Want it to come off.
Yeah, exactly.
It's a good failure mode.
But yeah, I mean, this especially the stronger industrial kind of Velcro is really pretty good stuff. We also made it to where you could quickly zip tie them down. So I don't know if you hold it up to the light and look through, but there's basically these on the corner that are molded in, and then these that are molded around our inserts, our bolts. So you can mount them on the side, you can mount them, and this is on the, should mount pretty well on the 1/2-inch perf board, the perforated plastic board or Luan board. So here are, you mentioned putting these on robots. This is exactly what the alpha program and beta program is about. And this is more for teams that have already been doing this, just what you'll have to relearn or adjust to. So these are some of the robots that were in the alpha program. So we can see that they've got their, I didn't have a picture of the voltage regulation module, but it is a slightly more capable version of the little anodized silver thing. You have one on there somewhere, right?
It's under our power distribution board.
Okay, so we're not going to look at it. But anyway, it's basically it takes a 12 volt and gives you a dedicated 5 or a protected 12. So there's that. There's the pneumatics. The PD is here. It's the big thing. And this is what their RoboRio looks like. So, and you'll notice almost none of the alpha teams did anything with their cabling. They ran it like this. So there's a better picture of it. So you know, here's the speed controllers and those other 2 modules I mentioned, the PD. And this was everything without the plastic. We've been doing this for about 6 months. So.
Those are the same snap action breakers that we use now? Okay.
I noticed on the PD board, or PD panel, you called it, there's a, looked like there was a cover that goes on top of the battery mounts.
Yeah.
To protect those, so.
Good idea.
Yeah, so if people drop a tool in, you're not shorting across the.
You can't drop the wrench like you could before.
Yeah. So you can have the little vertical bar like we have in the PD now, so a piece of metal cannot bridge the gap. It's got to go over.
No, there's a full cover. It's a plastic cover that's gonna, I'm assuming, gonna be required to be on.
It's like
there.
what you have under the hood of your car or in a boat
Yes.
or whatever. It's going to cover the terminals.
Because right now, if you were to run it just that way, they're way too close together because of the CAN module and stuff. That it would be scary.
Right, and I even ours and I don't have the cover on it, so I know they have the cover final now and they're getting them produced, but I don't know exactly what
You
the
had it
cover
in
looks
your
like.
picture. It was pictured in your screen.
Yeah, that was a rendering.
Right.
So
yeah, and they have the 3D printed.
Take that for what it is.
Right. And they have the 3D printed one at Championship.
Yeah.
Because we were playing with it.
I saw that and never connected what it was.
at this point, we were using this enormous USB dongle for the radio, and I do have one of those somewhere, but that's not the radio we're using this year anyway. The story about the radio, the radios that are used in FRC are something close to this. It's not this brand, but they're basically a combination bridge, a Wi-Fi. It's just an off-the-shelf thing you would get for your office, your printer, your entertainment center, or whatever. They're not that rugged. It's expensive to design your own. You're not really going to find one that's from automotive or aerospace that you're going to be able to use on the robot. So, the worst thing about them is they're closed. They're consumer devices. You're not supposed to be able to mess with them. So what we were looking at using was, I had it out a minute ago. Go back in here. Yeah, here it is. It was actually this guy. And we actually looked at several different options. One was integrated Wi-Fi. So it would be like your phone or your tablet. It would be a Wi-Fi device. There would be nothing you would add to it. And that's actually what we did with the MyRio. But we weren't really able to get a good chip that would do all the things it first wanted. First wants it to be 5 gigahertz. First wants it to be high bandwidth. So this was plan B, which was to put it on a memory stick that was, again, off the shelf, but something that we have the drivers for. So that we can actually get a lot more diagnostics and do a lot more control. And we're not having to reprogram the radio. We're just putting a manifest on a certificate on the robot saying, here, encrypt it, or set it this way or set it that way. Anyway, we ran into problems with the drivers. We gave it a go. So we're going to stick with this kind of device for another year. And we still have a couple other options on the table. We're going to continue trying to improve the radio situation.
So they didn't settle on going back to the old one or anything. They don't.
That's almost certainly going to be what happens if they can get quantity that they need. So
with the Rev Bs.
Yeah, it's a known entity. So and this was again just showing off different teams and the way they mounted it. Some of them did them upside down. Some of them did it on a flip up panel. There's a PD. There's one that's shoved inside. So
They insulated them.
yeah. So some people had stuff that let the LED on the bottom glow. Really cool.
So can a camera connect to the radio like it does now?
Yes. So if you want, so the cameras are interesting, and I have a couple different ones in here. So for the people who haven't seen them, gotta get them out. Here we go. So this is the kind of camera that FRC has been using the last 5 or 6 years. This is an IP camera or a security camera. They're not. I mean, I worked with Axis years ago to try to get a pretty good one. This is one of the least expensive they make, but they're a pretty good brand. We had a lot of lag, a lot of latency from like your D-Links and your Linksys and some of those others. So Axis actually has some pretty good chips in this and does a pretty good job. But they are over $100. So this is still an option. It still works. The software still supports it. It's still a good choice. And now you have, I actually bought a range of these all the way down to like, under $10. Those were really bad. The lenses were just like, I don't know where they got them from, but they were horrible, So this, Microsoft had a good $15 one. This is the next step up from that. I bought $100 ones, that are like HD quality and all that kind of stuff, and you just end up turning all those features off because you don't really need HD quality to process or to look at, So really, the good news is like a $20 camera is just about right. That's all we really need most of the time. If you want a better camera that you're going to process a portion of the image and you want a high-res camera, yeah, they cost less than the Axis did. So the camera stuff is actually quite a bit easier. Also, the host here is USB 2.0. But we do quite a bit with imaging companies. So Basler has is a camera company that does industrial USB cameras, and they have cameras that work on our controller, even though it's USB 2. It's a USB 3 camera that will work just at reduced rates on the Robo Rio. So if you want an industrial camera with industrial lenses and filters and all that other good stuff, that's now supported.
What was that?
Basler?
BASLR?
Okay.
You are, I think.
We need
Yeah.
to wrap up soon for
Yeah,
the
yeah.
night.
Are they gonna have specific cameras that I've stepped out?
In the kit, or?
No, I mean, or recommended for the robots, is the $10-15 cameras, are they gonna hold up to some bits, or are they just gonna kinda?
So a lot of teams have used USB cameras, and in 2012 we ran one through a BeagleBone before, and literally it was actually we took the whole shell off of it and just mounted it on a piece of Lexan, and it was just a little board running a USB cable, and it ran fine through the whole year.
I just worry about durability, especially after this last game.
Right, and it depends on how you mount things and change things, but you can crack them open, take the board, and make 3D print your own ruggedized case for it, or whatever you want to do.
Yeah, I think, again, you're going to find some issues with some of the manufacturers, but I think in general they're going to be pretty sturdy.
Okay, I just worry about people teams complaining during the match. Yeah, well.
Yeah. Yeah. Well, the other thing that's funny about these is they're almost impossible to mount. I looked and looked, and they've got all kinds of goofy things on them. For
That's
like
why we took them apart.
Resting on top of your monitor, and they're just horrible for that. But you know,
Mount your computer on there and you mount that.
that's why 3D printers were invented. So
We
make your
just
own little houses.
we just completely disassembled it, just had the board and zip tied it to a piece of Lexan, and it worked fine.
So real quick software stuff. There's going to be some nice stuff happen probably with Discovery. So if you haven't done this before, you don't know what you're missing. But static IPs were what first used for the field and for the. So you ended up setting up a bunch of static IPs, and it was always the wrong one, and it was hard to get back online. And so we're running in DNS, and so that's probably the way most of this is going to go, to where you just name your devices and they find each other. So that's quite a nicer. You now have USB as a connectivity option. You know, for your kids who like to hack with Linux or are good hackers, things like SSH, SFTP, WebDAV are built in. We also turned on the FTP, the old FTP client server, so that works too.
That's nice.
That also worked on C-Rio, but I mean, there's more. And the kids shell in, and you can run PS and whatever you can trace, and you can pipe things, and they can really have fun with it. And again, it's either over the USB cable or over an Ethernet cable, just like they would any other little embedded controller.
Wireless too, right? If they're running
wireless,
wireless.
Yep.
Can I put a hub on the USB host?
You can.
Okay. Cool.
Yeah. Put one on that works. That's another thing that they don't work. I don't know what's up with hubs, but they always fail. I don't know why, but especially the ones first handed out. So
I threw that one away and bought another one.
Yeah. It's quite a bit faster. So it's dual core. I think kids will have a lot of fun with it. You'll also be able to get tools and libraries on it a lot more easily than on the C-Rio, just because, VxWorks is a great operating system for what it was, but it's not as flexible. You're not. One of the reasons we didn't have USB on it before was it's almost impossible to get drivers for USB devices for VxWorks. You just don't use that on a missile, so. Right. So. The tools are going to be based off of Eclipse and GCC and Java Standard Edition. The stuff on the C-Rio was based off of a phone Java, so the Java's gotten quite a bit better. The C++ is more modern. It's C++ 11. The LabVIEW will be the 2014 edition. So all the software is getting more capability added to it. And I think that's about all I have. It's there. If you do have examples or tutorials or things out there, there is going to be a transition year. You are going to get some confusion. Like, oh, you're reading the instructions for the C-Rio. This is not a C-Rio. This is a Robo-Rio. Or, yeah, there's a new parameter.